ऑर्डर कमाओ, दो तो कम है, तो हमें नहीं पड़ेगा।
आवाज भी नहीं। पानी चाहिए।
Okay, please take your seats. Before we begin, there is a humble request that keep your phones on silent mode during the event.
कृपया अपने स्थान पर बैठ जाएं और आप सभी अतिथियों से अनुरोध है कि अपने फ़ोन को साइलेंट मोड में कर लें। हम कुछ ही समय में अपने कार्यक्रम को आरंभ करेंगे। Start. Shall we start? Okay. फिर से ये बोलो, फिर से रिपीट करो। फिर से
साइलेंट अभी सबने सीट्स ले रखी है।
फिर से बोलो।
So I request you again to keep your mobile phones on silent mode during the event. We are waiting for Joint Secretary also to join. So yes, so please have patience.
नमस्कार, आदर, अभिनंदन, आभार। कार्यक्रम के शुभारंभ करने से पहले यहाँ उपस्थित सभी अतिथियों से अनुरोध है कि कृपया गर्व और देशभक्ति के साथ राष्ट्रगान के लिए खड़े हो जाएं।
जन गण मन अधिनायक जय हे भारत भाग्य विधाता, पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा, विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा, तव शुभ नामे जागे तव शुभ आशीष मांगे, गाहे तव जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 हे।
आप सभी का बहुत बहुत धन्यवाद और सभी से अनुरोध है कि कृपया अपना स्थान ग्रहण करें।
On this bright sunny day, a very good morning to one and all who have gathered here for the first ever SCL Startup Meet 2024. On behalf of SCL team, I Pritika
और मैं राजेश आप सभी का प्रथम SCL स्टार्टअप मीट 2024 में हार्दिक स्वागत और अभिनंदन करते हैं।
It's a great honor and privilege to welcome you all on this event, organized by Semiconductor Laboratory Chandigarh and sponsored by CDAC Noida.
इस अवसर को अपनी गरिमामयी उपस्थिति से गौरवान्वित करने के लिए हम इलेक्ट्रॉनिकी और सूचना प्रौद्योगिकी मंत्रालय के अतिरिक्त सचिव माननीय श्री भुवनेश कुमार जी के प्रति हार्दिक आभार व्यक्त करते हैं। सर, हम आपका हार्दिक स्वागत करते हैं। महानिदेशक SCL से अनुरोध है कि पौधा भेंट कर अतिरिक्त सचिव जी का सम्मान करें। धन्यवाद सर।
To grace this event, we are also honored to have Shri Sushil Palji, Joint Secretary, Ministry of Electronics and Information Technology. Sir, we welcome you. And we request Executive Director, CDAC, to kindly present him with the plant pot. Thank you, sir.
हम यहाँ पर उपस्थित इलेक्ट्रॉनिकी और सूचना प्रौद्योगिकी मंत्रालय के अधिकारियों का, संपूर्ण सीडैक टीम का, भारतीय सेमीकंडक्टर मिशन के सदस्यों का, भारतीय स्टार्टअप्स के प्रतिनिधियों का, एकेडमिया के प्रतिनिधियों का और जिन्होंने इस कार्यक्रम में अपनी उपस्थिति दर्ज कराने के लिए अपना बहुमूल्य समय निकाला है, का हार्दिक स्वागत एवं अभिनंदन करते हैं।
Last but not least, I welcome our SCL colleagues and participants who are present here personally and connected with us online. With this rising semiconductor era in India, Indian semiconductor ecosystem has gained substantial momentum, strengthened by the government support. The only integrated device manufacturing facility in India, that is Semiconductor Laboratory, has taken this opportunity to step ahead and showcase its capabilities, inviting all Indian semiconductor startups to connect, collaborate, catalyze the change in India's semiconductor ecosystem.
SCL ने स्टार्टअप मीट 2024 के विचार की कल्पना एक ऐसा मंच बनाने के लिए किया है जहां सेमीकंडक्टर के क्षेत्र में भारतीय स्टार्टअप विकसित हो सकें, फल फूल सकें और SCL की इंटीग्रेटेड डिवाइस मैन्युफैक्चरिंग अर्थात IDM सुविधाओं का लाभ उठा सकें और हम सब मिलकर हमारे यशस्वी प्रधानमंत्री श्री नरेंद्र मोदी जी द्वारा दिए गए लक्ष्य सेमीकंडक्टर के क्षेत्र में आत्मनिर्भर भारत और विकसित भारत 2047 को प्राप्त कर सकें।
So please, let's join and begin the event by seeking the blessings of Almighty Supreme Lord.
साथियों, इस मीट का शुभारंभ हम उस सर्वशक्तिमान ईश्वर का आह्वान दीप प्रज्वलन से करते हैं और विनती करते हैं कि वह उसे सफल करें। इसके लिए हम मंच पर आसीन गणमान्य अतिथियों से दीप प्रज्वलन करने के लिए आमंत्रित करते हैं। डायरेक्टर SCL और एग्जीक्यूटिव डायरेक्टर सीडैक नोएडा से भी अनुरोध है कि वे इस पल के सहभागी बने।
शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः। शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः।
आइए चले अंधकार से प्रकाश की ओर।
दीपज्योतिर्नमोस्तुते।
प्राणी की परमात्मा की ओर
और एक पर्याप्त अज्ञान से ज्ञान की
आरोग्यं धनसम्पदः। शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः। शत्रुबुद्धि विनाशाय दीपज्योतिर्नमोस्तुते। दीपज्योतिर्नमोस्तुते। शुभं कुरुत्वं कल्याणं आरोग्यं धनसम्पदः।
धन्यवाद सर। India's bent towards growing its semiconductor ecosystem dates back to 1976, when the then Cabinet of India granted its permission for the formation of Semiconductor Laboratory in Chandigarh, Punjab.
सन 1983 में खूबसूरत शिवालिक पर्वतों की तलहटी में स्थित SCL ने सन 1984 में अपना उत्पादन शुरू किया और कुछ ही समय में 21वीं सदी की कंपनी बन गई। इन वर्षों में आज तक SCL भारत की पहली और एकमात्र एकीकृत डिवाइस निर्माता अर्थात IDM है।
SCL achieved quite early milestones in a short period of time and earned many firsts to its credit. SCL designed, developed and manufactured chips like electronic modules for clock and watch industry, dialers, speed circuit, toner ringers, codec chip for electronic exchanges, locomotive chips for Indian Railways, ASIC-based check signaling systems for State Bank of India are few names. Since its inception, SCL has partnered with academia too. Delivering unicorn microcomputers to Indian schools was one such project.
SCL में हम CMOS उपकरणों के डिज़ाइन, निर्माण, पैकेजिंग, परीक्षण और क्वालिटी एश्योरेंस सहित संपूर्ण समाधान प्रदान करते हैं। SCL ने सिस्टम ऑन चिप्स, एप्लीकेशन स्पेसिफिक इंटीग्रेटेड सर्किट्स, ऑप्टो इलेक्ट्रॉनिक्स और MEMS डिवाइसेस की डिज़ाइनिंग में भी विशेषज्ञता विकसित की है। हम अपने ग्राहकों को उच्च क्वालिटी की सेवाएं प्रदान करने और उन्हें उनके लक्ष्य हासिल करने में मदद करने के लिए समर्पित हैं।
So let's have a short video tour of SCL.
This is the story of the Semiconductor Laboratory, the Indian Silicon Valley. Nestled in the foothills of the beautiful Shivalik Range, Chandigarh, in 1981, Semiconductor Complex Limited was set up just outskirts of Chandigarh in SAS Nagar in Punjab. This was the first step in the country's journey towards self-reliance in the field of VLSI technology. Since then, SCL has grown and progressively gained strength, particularly in the areas of VLSI and micro-electromechanical systems, that is, MEMS. It develops and manufactures VLSI and MEMS devices, charged coupled devices, etc., and is today meeting critical demands of our nation. SCL operates on the philosophy of end-to-end product solution. Accordingly, the integrated operations at SCL encompass design, fabrication, assembly, packaging, testing, reliability and quality assurance all under one roof. From a vision to a concept, from a concept to an idea, from an idea to a design, from design to the final product delivery, the Semiconductor Laboratory is working tirelessly to meet the country's growing needs, continuously breaking new ground in the field of VLSI technology.
So once again, SCL with folded hands and open hearts welcome you all on this event.
SCL के महानिदेशक डॉक्टर कमलजीत सिंह का परिचय देते हुए मुझे अत्यंत हर्ष का अनुभव हो रहा है। सर सेमीकंडक्टर RF और माइक्रोवेव के क्षेत्र में अपने 25 वर्षों के अनुभव के साथ इस स्टार्टअप मीट के पीछे एक प्रेरक शक्ति रहे हैं और हमें अपने युवा, गतिशील और दूरदर्शी नेतृत्व के माध्यम से SCL का मार्गदर्शन कर रहे हैं।
So we would like to invite Director General SCL for his welcome address. Sir, please join us to the podium.
Thank you. Respected Additional Secretary, Joint Secretary, ED CDEC, MATI officials, dignitaries, startups, and my dear friend, Namaskar. On behalf of Team SCL and Team CDEC, I heartily welcome you all for this event. The Startup Meet is a unique event which provides a platform for Indian startup to connect, collaborate, and to utilize India's own foundry. The idea was to tap potential of startups and showcasing the potential of the extraordinary talent which our country possesses in this field. This idea gained momentum when we interacted with one of the startup, and it comes out with a very successful IP in our portfolio. As a designer, one wants that there is a curiosity that once I design, the product should come out, and I should be very eager to know that what is my end results, which encompasses fabrication, apart from design, assembly, testing, packaging, and in some specific conditions, we want screening and qualification also. The SCL provides you all this type of platform at one place. We have a one-stop solutions. I have a brief presentations for you. I will give you the capabilities what SCL possesses. We are a unique IDM. Next slide, please. In 1976, the cabinet approved the formation of SCL with a budget, with an outlay of 50 crores, and we have an agreement with AMI USA to acquire 5-micron technology on a 4-inch wafer. The SCL started its commercial operations in 1984. We have successfully completed 40 years of our operations. We developed 1.2 micron technology in 6-inch fab line with AMS. And in 2010, a 180 nanometer technology node was transferred, and 13 and 14, this technology node was successfully come in the production. We have ex-directors also with us, from the initial days to the last director also with us. We have a unique IDM. The capabilities lies not only in R&D activities, we are doing lot of things in outreach, in skill development, as well as we are having international collaborations also. We have given more than 1 lakh chips to ALICE project. We are working in the next ALICE project also. We have given some 30,000 chips to GSI Germany. We are also doing some outreach program and skill development. Going with integrated device manufacture, we used to go from design to packaging to testing, as well as we are going with R&D with limited volume productions. Our portfolio consists of optical devices, MEMS devices. We are doing system assemblies, packaging and screening. We have a red hard capability. We have 2 lines. One is a 6-inch line, which takes care of 1.2 micron technology, where we are using it for MEMS as well as detector fabrication. We have a 8-inch line, which we are giving it for. It is 180 nanometer node, which we are catering for strategic sectors and other applications. Going with our product portfolio, we have both 6-inch line and 8-inch line, where 8-inch line is basically working on analog, digital, mixed signals, RF, CMOS, logic. We are also working on high voltage, which is our R&D activity. Going with our 6-inch line, we are basically doing with detectors and lot of sensors, gyroscope, accelerometer. Recently, our accelerometer in MCM package has flown in SSLV missions. We are also doing lot of imager devices, and our R&D activities in compound semiconductor is also going, and there is a porting of the process also successfully going on. Now comes to the top figure. If you can see there, what we have done is we have done the integration of detector in a vertical integration with ROIC. So this is also a unique capability which our foundry possesses. Going with one-stop solutions, we can give you design services, design enablement, lot of portfolios are there, foundry platforms are there. We have a foundry solutions, back-end solutions, and turnkey solutions. We are working with lot of sectors. We are working not only with strategic sectors, we are working with railways, we are working with meteorological department also, and nowadays we are also started commercial things. Going with our interactions, we have doing a lot of interactions with academia. Lot of IITs, prominent IITs are partner with us. I think IIT Bombay is represented today, IIT Guwahati is there, Delhi is there, ISCs. We have also a collaborations with startup, where MNST, Chakradhara, Third IT, Dhruva Space, I think most of them are today here itself. We give lot of emphasis on documentation. Knowledge sharing is one of the things which we are taking care, and that is why with industry, academia, and project trainings also we are running lot of programs like FDP programs, C2S, SMDB, skill development. We are also giving emphasis on indigenizations with the collaborations with academia as well as with industry. Going with SCL, we are emphasizing SCL as an ecosystem enabler. So today this meet is only for in that direction, where we want the startups to utilize our shuttle run programs, and it can be launched as IV blocks from them. It can be useful for SOC. We also want R&D both in product as well as in process. We are looking forward for that. We are doing lot of interactions with academia in these directions. We are an original device manufacturer, so we are giving the prototyping mask services also, and it can be useful for limited manufacturing, and because we are a mirror image of Tower Foundry, so bulk of the volume can be taken from Tower Foundry also. Going with power of 180 nanometer node, 180 nanometer is a very hot node. It is also known as a sweet node. You can see still the 20% market, around 20 billion is there, still there. It is easily maintenance is there. We can have a extremely low cost. The major impact is because it is highly reliable. If you go for the advanced node, there is a degradation in AFR, annualized failure rate, which increases 3 times more once you go for advanced node. Also, you get various flavors in 180 nanometer, which is very difficult to find out other nodes, and it is still preferable with automotive industry because it is highly reliable. Lot of industries is coming, 20% is still coming every year in 200 mm node, and it can be useful for medical as well as in your mobile phones also. Lot of devices in 180 nanometer are still there. Going with SCL offerings, so today we are offering you that multi-product shuttle runs. We are tentative spots we'll reserve for you. It's already there on our website. We used to have quarterly programs. It is a one-stop solutions where we can provide you packaging. You can leverage the expertise which we are having in packaging, testing, as well as in qualification. Going with working with SCL, you have a uniqueness because we have a highly reliable fab. It is a JADEC qualified. We are soon going to be ISO certified lab. We are also having a smart sensing applications. We are also having testing and characterization facilities. If you associate with us, the thing is we can create a lot of IP banks which will enable the production grade IP as well as high-end products. It will leverage and showcase your capabilities to the world over. It will create products linking the country requirement. It will optimize the resources as well as we are very much transparent. So SCL cater to national requirements and we are looking forward to have a wider IP portfolio. India is becoming a key player in the global semiconductor landscape and rapid expansions of wider varied applications needs cutting edge solutions. So today this meet, we are hopeful that you will bring innovations with collaborations, knowledge sharing, and it will provide a platform to you for leverages this SCL expertise. Hopeful that this day-long session will provide you valuable insights. Thank you very much for your sparing your valuable time to be with us today. Thank you very much.
धन्यवाद सर.
Thank you, sir. Thank you so much. The Center for Development of Advanced Computing, CDAC, was established in 1988 to develop India's own supercomputing capabilities. CDAC was created in response to the US government's refusal to sell India a Cray supercomputer due to concerns about India's nuclear weapon programs.
CDAC's first supercomputer, Param 8000, was released in 1991. The Param 8000 was 28 times more powerful than Cray XMP that the government had originally requested to US government. CDAC's areas of work include Indian language computing technologies, education and training, health informatics, cyber security, cyber forensics, e-governance, and many more.
Let's also have a very short video tour of Chip-in Center of CDAC.
Semicon India Future Design, Chip-in Center, catalyzing chip designing in India. The Indian semiconductor market has been gaining momentum since the last 1 decade, and design in India will be equally important as Make in India to contribute to India's fast-growing digital economy.
Almost all of the top 25 semiconductor design companies have the design and R&D centers in our country.
The global semiconductor market is anticipated to reach $820 billion by 2028. It is envisioned to transform India into a semiconductor hub, including semiconductor design. Chip-in Center is established at CDAC, Bangalore, as a first-of-its-kind initiative by Government of India, providing opportunities to startups, MSMEs and academia for semiconductor chip design. Chip-in Center removes barriers to enter chip design for young entrepreneurs by offering facilities from design to fabrication support in multi-project wafer (MPW), by enabling access to SCL and overseas foundries. Chip-in provides centralized EDA design tools and IPs, fab compliance checks, validation and integration of designs, enablement of packaging of fabricated chips, enablement of characterization and prototyping in a centralized manner, mentoring researchers and startups for chip design, virtual prototyping lab at NILIT Calicut, facilitating remote access of high-end electronics, hardware, diagnostic equipment and FPGA boards and tools to startup and industry. Calling upon all the semiconductor professionals, from startups, industry and academia, to make India from chip taker to chip maker, and trigger future wave of semiconductor startups and unicorns, towards fulfilling India's aspiration to become a major player in the global semiconductor ecosystem.
Now we would like to invite dynamic, creative and result-driven technology leader, Shri Vivek Khaneja ji, Executive Director, CDAC Noida, holding 3 decades of comprehensive experience in high-performance computing and embedded system domain. Sir, we welcome you and invite you for an introductory address.
Good morning, everyone. Respected Bhuvnesh Kumar ji, Additional Secretary METI, Shri Sushil Pal ji, Joint Secretary METI, Shri Kamaljeet Singh, Director SCL, all dignitaries who are gathered here, representatives from startups, academia, industry, and everybody who has joined online, SCL team from CDAC. Welcome to this event of Startup Meet, rather, where we are meeting today to collaboratively look at the opportunities that exist today, both coming from the government and also how we could collaboratively work to make India a product nation. Semiconductors has been the heart of many revolutions in all world over. And in the last 1 decade or so, we have seen India taking giant strides and leaps into this domain. Realizing the importance of the semiconductors, the Government of India has launched several programs, both from the point of view of adding teeth to the electronic manufacturing industry through the PLI schemes, and also the design incentive schemes for incentivizing the designs in addition to the semiconductor fabrication facilities through the Indian Semiconductor Mission. The global semiconductor market is expected to grow almost at a rate of around 15% CAGR, going to almost $1 trillion by the end of this decade. In India, we are starting from less than 5% of the global market share, but we target to be 10% of the global market share of the 1 trillion economy, targeting almost $110 billion by the end of 2030. And the semiconductor ecosystem is thriving, and realizing this, a lot of incentives have been put in place. There are certain factors which are going in favor of India in terms of the demographics that we have. We have a fairly young and vibrant set of designers, a very large number of universities that are churning out highly skilled graduates, which can contribute to the development of newer products and designs. We also have a large number of PhDs that are coming out, and because of the skill capital that we have in India, I think it becomes incumbent upon us as a nation to strive to create innovative products, not only for India, but also for the world. Realizing this, the Government of India has taken a multi-pronged approach and created several initiatives. One of them, the largest one, has been the Indian Semiconductor Mission, which today has a budget of almost 76,000 crores for setting up of the fabs, CMOS fabs, the display fabs, the ATMP and OSAT facilities, and also for the compound semiconductors. In addition to that, on the design side, we have about 1,000 crores earmarked for incentivizing the design community in this country by giving them incentives, both fiscal incentives as well as creating a design infrastructure support system, which includes making available the EDA tools, making available the IPs, and giving them access to the fabrication facility of SCL and others using the multi-project wafer modes. Under this scheme, so far we have evaluated several proposals which have come from the industries, and we have so far funded 14 startups who are working in some of the cutting edge product designs, which we will start to see in the coming months. In addition to that, about 35 startups have been provided access to the EDA tools from Cadence, Synopsys, and Siemens, apart from the support that we are also getting from Keysight and others. All this has been put together, and we have created a chip-in center at CDAC Bangalore, which provides the facility for virtual prototyping, which gives support for hand-holding of the startups for doing an MPW runs in various fabs. Regular design flow trainings are being conducted both with the help of SCL and with IMEC. And of course, we are providing a large set of EDA tools. Recently, we have announced a specific call for proposals based on the products identified under the Product Nation strategy of the Government of India. And we encourage all these startups and MSMEs to look at these products, and if you have innovative ideas, please feel free to come to us with your product ideas for being a DLI funded startup. We have also now announced availability of emulation platform, Veloce, which the startups which are incubated under the DLI schemes will have full access to. Recently, we have tied up with Synopsys to make the Synopsys IPs available at a fraction of the cost to the DLI applicants. Most of you will realize that a major cost of the semiconductor design today is the IP cost and also the EDA tools cost, and of course the major contributing factor to the cost is the manpower cost. So all this is being supported thanks to the initiative of the Government of India under the DLI scheme, and we encourage all the startups and MSMEs to take full advantage of these schemes. In addition to the Synopsys IPs, we have also agreement with ARM to make their IPs available free of cost for MPW runs. Under the SMDP program, or the Semiconductor Manpower Development Program, now called the Chip to Startup, several academic institutes and research institutes have been supported both at the EDA tool level and also on the capacity building side. And so this is just a glimpse of all the major activities, both in terms of the EDA tool support, the number of cores, IP cores which are being developed, the emulation platform, access patterns, and so on. So to summarize, I would encourage all startups, MSMEs to be a part of this movement. Let us all create a good and a vibrant semiconductor ecosystem in this country, so that we are not only contributing to the economic growth of this country, but we are also helping India to become a major global player in the semiconductor supply chain. So to be I think it's the right time to be a semiconductor design startup, as our Honorable Prime Minister says, "Yahi samay hai, sahi samay hai." So thank you, and we look forward to collaborating with you.
धन्यवाद खनेजा सर। हम आशा करते हैं कि SCL और CDAC मिलकर और ISM और MIT के सपोर्ट से भारत को सेमीकंडक्टर के क्षेत्र में अग्रणी बनाएंगे।
Now we would like to welcome Shri Sushil Palji. Sir, a very warm welcome to you. With over 23 years of extensive experience as a civil servant in various ministries of Government of India, Sir is serving currently as the Joint Secretary in Ministry of Electronics and Information Technology.
He is primarily responsible for execution of various electronics manufacturing schemes like semiconductor PLIs, mobile and IT hardware, investment promotions activities. Besides this, he is also in charge of International Cooperation Division and Internet Governance Division. Sir, we welcome you for your address.
Thank you. Thank you so much. My senior colleague, Shri Bhuvanesh Kumar ji, Additional Secretary METI, DG SCL Kamaljeet ji, ED CDAC Vivek Khaneja ji, the delegates from academia, the startups, and my colleagues from MIT. I mean, very good morning to you all, and let me begin by congratulating SCL and CDAC for organizing this this interaction or this event involving the startups, academia, and policymakers, as well as the SCL, showcasing as to what all SCL does as a single one, or the one and the only one RDM facility in the country. I mean, as you all know, if India is to achieve its position as the third largest economy in the world, it cannot do without, without significant contribution from the manufacturing industry. And I mean, we as a part of the electronic industry have largely to focus on the electronic manufacturing part of it. We have made significant contribution in the past few years. We have been growing at a CAGR of almost 14%. And we have become actually the net exporters of the, from being the almost 70% importers of mobile 10 years back, we have presently become almost 100% self-sufficient in mobile. And we are also exporting mobiles and also exporting electronics to the extent of roughly $29 billion US. However, apart from this, I think whatever contribution we've been making so far, it has been largely been, on the lower end of the value chain. It's been largely in the assembly operations. And we, if the target of $500 billion is to be achieved, then we cannot do it without actually making India grow as a product nation, without developing its own product, not only the IT products, but also the semiconductor chips, the Indian semiconductor chips as such. I mean, we keep hearing that, we in India contribute roughly 20% of the design workforce, but this design talent or a skill talent, it nowhere compares with, how many design IPs or a semiconductor chips IP we own. I think it's negligible. I think something to do with the complete ecosystem as such. But then, yes, I think this workshop should be a trigger, should be a starting point in creating that ecosystem, and somehow, enable us or enable our startups who are sitting here to capture that higher end of the value chain in the electronic manufacturing. And as was shown by the EDC DAC in his presentation, that there were a list of the items, list of the chips, or which we need to focus on. So actually, we spread our resources everywhere. I think that was a part of the recommendation of the Product Nation Committee, wherein we suggested, which products to focus, and we also, it was suggested as which areas of chips we need to focus on. So we actually need to focus on the chips which are low value but high volume chips. I think that's only place where we can actually give a competition to the MNCs, or give a competition to the already established companies, right? So those are, I think, that simple chips like LED driver chips, microcontrollers, RF chips, Wi-Fi chips, 5G and 4G modems, and those are the places where I think our startups have a significant potential, and we should definitely pitch for a completely Indian IP chips in these areas. And one thing is for sure, that if we were to become a third, if you are to reach that $500 billion target, I think we cannot do without a few startups, rather ESGM startups, turning into a unicorn. And I'm sure we'll in a few years down the line, I think we'll have a few unicorns sitting among us. And by organizing this event, SCL has taken a very bold step. It has not only set a high benchmark for itself, and being bold enough, to come out in meeting the expectations of the startup industry. It has also raised the expectation of the startup and academia who are sitting here. I think they have far more expectation from SCL going forward. And I don't think, as of now, the startups actually, they are designing chips using the SCL PDKs or getting the tape out from the SCL as of now. Most of the tape out is being done by the academia, if my understanding is right. And we need actually to, kind of introspect and understand as to what is the reason that, we are not able so far to attract the startups that they start using the SCL PDKs. I think, and the SCL as a unit, since they have already ventured into this path, I think they must, they must make sure that all their SCL PDKs are fully compliant with the prominent EDA tools which are there in the market, which are being supported by the Chip-in Center. So there should not be a disconnect between these two, that the EDA tools which the Chip-in Center is providing, or which are being provided as a part of the DLI scheme, they are not being supported, they are not compliant with SCL PDKs. I think that's one gap which SCL needs to focus without any delay. And apart from that, a couple of other, there are few factors, which any startup, depending upon which the startup choose as to whether to get the chip fabricated here or to send them abroad, to get fabricated by the likes of TSMC and all. And these are the performance, price, and cycle time. And all of them are correlated, right? So I think SCL, I think we need to as understand the best of the industry, in the world. They have a turn cycle time of whatever 3 to 4 months. However, I think we are much lagging behind in reaching that cycle time. We need to promise that to the industry. And even in terms of the price, I think if the MPW shuttle is ready or full, then it's fine. Then the price point is okay. But many a times, because of the long delay in getting that MPW shuttle ready, I think that also leads to a significant delay in the getting the chips fabricated. And if we do it early, then it directly impacts our price, because you don't have enough chips to populate that wafer, right? So, but we have to think of all these factors. I think we need to create that critical mass, so that the shuttle gets ready within a 1 month's time. I think those are the issues we need to think. How do you create that? How do you create that critical mass? That's important. And what I also feel that SCL must also come out clearly, since they're engaging with the startups. They need to clearly come out with a charter of its own, clearly publishing what services they offer and at what price and what rates they offer. That's very important, right? Because we as a Bhubaneswar would agree that in most of the ministries, every ministry comes out with a citizen charter, right? There's a clear list of the services which are being met by the industry, met by the ministry, and in what time frame those issues are, those services are to be delivered. In a similar way, I think SCL needs to make that kind of a commitment, to the community here, that these are the services we offer and these are the rates we offer, so that there's a complete transparency, and there is also a definitive sense of certainty in the community when they make these choices while designing the chips and while getting them taped out. So, just for the information, I think METI has already started the proposal for restructuring of the SCL, which is actually to increase the wafer stats quantum every month, which SCL is will be coming out with. It's roughly more than 50 times or 100 times than the present tape out capacity. Not the capacity, rather the present tape out quantity which is being done, and also to increase, improve the cycle time by providing much needed redundancy in the equipment which SCL has. And we are soon will be coming out with RFP very soon, and it's under advanced stage of examination. It has been done with active consultation by the DG SCL and his team, but yes, the restructuring part will take care. But yes, I think what I also feel that SCL also needs to have its own business development team, right? I think it actually needs to behave like a corporate. It actually needs to become like a TSMC. If it is to become like a TSMC, the culture of SCL has to change. There has to be a separate business division which should be taking care of all the business requirements of the industry and the startups, and they should be providing the services needed to them just as a corporate, because all being done on a charge basis. And that's one thing for sure, that it cannot be run as a business as usual. And if we have to become, the SCL is to become the TSMC for tomorrow for India for at least 180 nanometer node, which I'm sure, I think SCL is capable of, it's competent under the able leadership of DG SCL. I think we need to change this culture. I'm sure we would reach there. And on that note, on a concluding note, I hope that you all will indulge into a very engaging discussions, will come out with a very valuable feedback, and would also make use of the SCL facility. And this should be definitely the start of this should be the beginning of a new work culture leading to the creation of an ecosystem for semiconductor chips design and its tape out. Thank you so much.
Thank you, sir. So surely SCL will work on all the points highlighted and will come with the practical solutions. Thank you for showing us such a direction and highly encouraging words. We have Shri Bhuvnesh Kumarji, who has graced today's event with his presence. He is a senior IS officer of 1995 batch. He has a vast and dynamic experience in administrative services. Currently, he is serving as Additional Secretary in Ministry of Electronics and Information Technology.
Sir is looking after cyber laws and data governance division, research and development activities in Ministry of Electronics and Information Technology, matters related to UIDAI, CMAT and CDAC and many more. Sir, we humbly request you to grace this occasion with your words.
बहुत बहुत धन्यवाद आदरणीय श्री जरावी साहब, श्री सुरेंद्र सिंह जी, प्रोफेसर उदयन गांगुली साहब, has come all the way from Mumbai, श्री पंकज गुलाटी जी from CDIL, he has joined us, मंच पर आसीन श्री कमलजीत सिंह जी, डॉक्टर कमलजीत सिंह जी, DG SCL, श्री सुशील पाल जी मेरे साथी मिनिस्ट्री में, श्री विवेक खनेजा जी CDAC से। आज के इस कार्यक्रम में विभिन्न सरकारी संस्थानों से पधारे हुए हमारे साथी, मेटी से हमारे कलीग्स, CDAC SCL से आए हुए और अन्य सभी संस्थाओं से जो भी यहाँ पधारे हैं, और आज के जो मुख्य आकर्षण हैं हमारे लगभग 30 के करीब आए हुए स्टार्टअप्स, मैं आप सबका बहुत हृदय से स्वागत करता हूँ। मुझे बेहद खुशी है कि SCL ने इस पूरी कड़ी में ये कदम आगे बढ़ाते हुए आज की इस परिचर्चा को आयोजित किया है, जिसमें SCL और स्टार्टअप्स कैसे साथ में मिलके सेमीकंडक्टर के जो हमारे सपने हैं देश के, उसको कैसे आगे बढ़ा सकते हैं। तो ये बहुत ही सराहनीय कदम है, मैं इसकी बहुत भूरी भूरी प्रशंसा करता हूँ, बहुत तारीफ़ करता हूँ। मेरे लिए SCL एक बहुत पुरानी याद है। मैं जब 84 से 89 के बीच में REC कुरुक्षेत्र में पढ़ता था इलेक्ट्रॉनिक्स इंजीनियरिंग में, तो सेमीकंडक्टर कॉम्प्लेक्स लिमिटेड, तब इसका नाम यही हुआ करता था, SCL की फुल फॉर्म थी सेमीकंडक्टर कॉम्प्लेक्स लिमिटेड, मोहाली में ये स्थापित थी। और हम लोग जब माइक्रो इलेक्ट्रॉनिक्स और VLSI पढ़ते थे, बहुत सारे लोग तो नहीं, लेकिन जिनका ये फेवरेट सब्जेक्ट होता था, उनके लिए सपना होता था कि हम सेमीकंडक्टर कॉम्प्लेक्स लिमिटेड में जाएंगे। वहाँ तक तो नहीं पहुँचा मैं, लेकिन मैं पंजाब कम्युनिकेशन लिमिटेड तक पहुँचा, PCL में मेरा सिलेक्शन हुआ। हालांकि उस समय मोहाली में 89 में जो डिस्टर्ब पीस का टाइम था, और उसकी वजह से मेरे परिवार ने मुझे वहाँ जाने नहीं दिया, तो मैं SCL से थोड़ा दूर हुआ। लेकिन इसी मंत्रालय की दूसरी जो PSU थी CMC लिमिटेड, वहाँ मैंने ज्वाइन किया 89 में। तो मेरा इस मंत्रालय से किसी ना किसी तरह से नाता बना ही रहा, और लगभग 30 साल बाद मैं वापस इस मंत्रालय में एज जॉइंट सेक्रेटरी आया और फिर यहीं एडिशनल सेक्रेटरी हुआ। तो SCL की बहुत पुरानी और बहुत अच्छी यादें हैं। जब भी वीकेंड पे हमको टाइम मिलता था, क्योंकि चंडीगढ़ लगभग 2 घंटे का ही रास्ता था वहाँ से, तो हम लोग चंडीगढ़ चले जाया करते थे, और इस तरह के संस्थानों को बड़ी ही आशा की नज़रों से देखा करते थे और अपने भविष्य को उसमें तलाशते थे। लेकिन CMC में आए और हार्डवेयर मेंटेनेंस में घुसे, डिज़ाइन को छोड़ के। लेकिन समय ने ऐसी करवट ली कि टेक्निकल साइड को छोड़ के एडमिनिस्ट्रेटिव साइड में आ गए, और इंजीनियरिंग को जो है एक तरफ रख के प्योरली एडमिनिस्ट्रेटिव ऑफिसर हो गए IAS में सिलेक्शन होने के बाद। लेकिन वो पढ़ाई का जो एसोसिएशन है और जो विषय की एक आपकी फीलिंग्स होती हैं, वो हमेशा जुड़ी रही और कभी भी समाप्त नहीं हुई। और इसीलिए जब यहाँ आने के बाद सेमीकंडक्टर मिशन स्टार्ट हुआ और उसमें डिज़ाइन लिंक्ड इंसेंटिव स्कीम शुरू हुई, तो एक बार फिर से वापस उसी फील्ड के साथ में नाता जोड़ा। लगभग 76,000 करोड़ की लागत से, जो उस समय $10 बिलियन हुआ करता था, भारत सरकार ने इंडिया सेमीकंडक्टर मिशन शुरू किया। बहुत ही महत्वाकांक्षी योजना थी। एक समय जो हमने अपॉर्चुनिटी खो दी थी, उसे वापस सही समय पे हमने फिर से पकड़ा है। जैसा खनेजा साहब ने भी कहा कि यही समय है और सही समय है। सही समय पे वापस हम सेमीकंडक्टर की राह पर आ गए हैं। कोविड ने और जियोपॉलिटिकल सिनेरियो ने हमको ये दिखा दिया कि चिप्स की आज के वर्ल्ड में क्या इम्पोर्टेंस है और कैसे सारा का सारा प्रोडक्शन रुक सकता है, और न केवल इलेक्ट्रॉनिक्स में बल्कि ऑटोमोटिव में, हेल्थ केयर में या और फील्ड्स में किस तरह से चिप्स पूरे सप्लाई चेन्स को कैसे एडवर्सली अफेक्ट कर सकते हैं, कैसे उनको पूरी तरह से रोक सकते हैं और पूरा का पूरा प्रोडक्शन बंद हो जाए, गाड़ियाँ बिकनी बंद हो जाएं, उपलब्ध होनी बंद हो जाएं। ऐसे में मुझे लगता है कि चिप वॉर एक्चुअली शुरू हो चुका था, और आज कम से कम 6 ऐसे देश हैं जिन्होंने स्पेशली सेमीकंडक्टर मिशन प्रारंभ किया हुआ है, और उसमें शिखर पर भारत है। जहां हमने एक और फाउंड्रीज़ के लिए प्रयास किया और 3 प्लांट ऑलरेडी सैंक्शन हैं, वो 76,000 करोड़ रुपए की धनराशि लगभग समाप्त होने के कगार पर है। उसी के साथ साथ एक डिज़ाइन लिंक्ड इंसेंटिव स्कीम भी शुरू की, जिसकी लागत 1,000 करोड़ रुपए रखी गई थी। खनेजा साहब ने काफ़ी सारे चीज़ों के बारे में उसके बताया। मुख्य उद्देश्य ये था कि किस तरह से हम भारतीय कंपनियों को डिज़ाइन के फील्ड में ला सकें, कैसे हम स्टार्टअप्स को सपोर्ट कर सकें। और जैसे जैसे हम उस स्कीम के डिटेल में जाते गए, क्योंकि पुराना अनुभव कोई नहीं था, तो आपके साथ मिलके ही हम सीख रहे थे। स्टार्टअप्स के जो पेन पॉइंट्स थे उनसे हम सीख रहे थे और उसको हम ठीक करने की कोशिश कर रहे थे। जितनी हमें अपेक्षा थी उस पर हम खरे नहीं उतर पाए, हम पीछे रह गए। जितनी हमें उम्मीद थी कि हम तेज़ी से स्कीम को ले जाएंगे, बहुत सारे स्टार्टअप्स आएंगे, बहुत सारी एप्लीकेशंस आएंगी हमारे पास में, जो DLI स्कीम में हम जिनको सहायता करके डिज़ाइन के फील्ड में एक बड़ा नाम कर पाएंगे, लेकिन वो काफ़ी धीमा रहा। केवल 14 स्टार्टअप्स को ही अभी हमने सेलेक्ट करके जो है उनको लेटर दिया है, ऑफ़र लेटर दिया है। उसमें से बल्कि 5-6 ऐसे हैं जिन्होंने अभी धनराशि ली है हमसे। EDA टूल्स ज़रूर हमने अवेलेबल कराए हैं करीब 34 स्टार्टअप्स को, बट वो मुझे लगता है कि एक बहुत छोटा और पहला कदम है, अभी उसके आगे जाने की ज़रूरत है। क्योंकि DLI स्कीम को भी हमने 2 भागों में बांटा। एक हमने कहा कि PDLI होगा, प्रोडक्ट डिज़ाइन लिंक्ड इंसेंटिव, और दूसरा होगा डिप्लॉयमेंट लिंक्ड, DLI होगा। अभी हम PDLI के भी पहले ही पायदान पर हैं। अभी DLI तक पहुंचना दूर की कौड़ी है, अभी हमें समय लगेगा वहां तक पहुंचने में, कि जब प्रोडक्ट डिज़ाइन हो जाएगा, फैब्रिकेट हो जाएगा, कमर्शलाइज होगा, और जब वो मार्केट में बिकेगा संख्या में, तब हम DLI इंसेंटिव, डिप्लॉयमेंट लिंक्ड इंसेंटिव दे पाएंगे। तो इसलिए अभी थोड़े दिन पहले ही हम लोगों ने इस फील्ड में जितने भी स्टार्टअप्स हैं जो पहले से हमारे साथ आ गए हैं, जिन्होंने टूल्स लिए हैं, जिन्होंने एप्लीकेशंस दी हैं, या और जो इच्छुक हैं, उनके साथ में एक मीटिंग की और उनसे समझने की कोशिश की कि उनकी ज़रूरतें क्या हैं। कुछ चीज़ों को आसान बनाने की कोशिश भी की, कुछ इंसेंटिव्स को, स्कीम के गाइडलाइंस को मॉडिफाई करने की कोशिश की। मुझे उम्मीद है कि उसका लाभ मिलेगा और नए एप्लीकेशंस हमारे पास आएंगे। लेकिन एक बहुत बड़ी जो ज़रूरत थी वो थी स्टार्टअप्स को किस तरह से SCL के साथ में भी लिंक किया जाए। निशित जी हमारे जो है ये फॉलो करते रहते हैं कंटिन्यूसली। एक दिन साथ में जो है इन्होंने पकड़ लिया डॉक्टर कमलजीत जी को मेरे साथ कि SCL जो है पर्याप्त नहीं कर रहा है, SCL को और कुछ करने की ज़रूरत है। तो मुझे बेहद खुशी है कि आज SCL जो कर रहा है स्टार्टअप्स के साथ में, और विशेष रूप से DLI के लिए हम लोग फिर अगले 1-2 दिन में चर्चा करने वाले हैं इस पे आपके साथ में। मुझे पूरी उम्मीद है कि जिस मंशा के साथ में, जिस उद्देश्य के साथ में ये कार्यक्रम शुरू किया गया है, ये स्कीम शुरू की गई है, ये योजना पूरी लागू की गई है, उसका सही लाभ हम लोगों को मिल पाएगा। मैं और अधिक से अधिक स्टार्टअप्स का आह्वान करना चाहूँगा कि जो इस फील्ड में काम कर रहे हैं और अभी कहीं दूर हैं, कृपया जानें हमारी जो सुविधाएं उपलब्ध हैं, जो SCL में फैसिलिटीज़ उपलब्ध हैं। DG साहब ने आज प्रेजेंटेशन दी, आपको बताया कि क्या क्या हम कर सकते हैं। जैसे आपने मुझे बताया कि आज जितने स्टार्टअप यहाँ आए हैं उनके लिए जो है शटल रन फ्री करने वाले हैं एक बार के लिए। इसी तरह से जो चिप इन सेंटर बैंगलोर में CDAC ने स्थापित किया है, वो DLI स्कीम का पार्ट है। वहाँ जो फैसिलिटीज़ उपलब्ध हैं उसका आप लोग उपयोग करिए अधिक से अधिक। EDA टूल्स हमने अभी एक सीमा तक खरीदे हैं और आपको उपलब्ध कराए हैं। IP की व्यवस्था की है हमने, लेकिन मुझे लगता है कि आपकी ओर से और अधिक मांग आनी चाहिए। जितनी डिमांड आपकी ओर से आएगी हम उतना और अधिक करने की कोशिश करेंगे। जितना हमारे पास रिसोर्स अवेलेबल है, जब ये कंज्यूम हो जाएगा तो हम इसमें और ऐड करेंगे। इसकी सीमा नहीं है, 1000 करोड़ की भी सीमा नहीं है। अगर हमारे पास अच्छे प्रस्ताव आते हैं, ऐसे IPs जनरेट होते हैं कि हमें इस सीमा को बढ़ाने की आवश्यकता है, तो हम निश्चित रूप से उसको बढ़ाएंगे, उसके लिए आगे जाएंगे। तो मैं यहाँ जितने भी लोग मौजूद हैं आज इस हॉल में यहाँ मौजूद हैं, मैं उन सब से यही कहना चाहता हूँ कि सेमीकंडक्टर के क्षेत्र में भारत अब जिस स्थान पर खड़ा है, जहाँ तक पहुँच गया है, वहाँ से अब हमें छलांगे भरने की ज़रूरत है। एक एक कदम चलने से काम नहीं चलेगा, तेज़ी से आगे बढ़ना होगा और हम सबको मिल के साथ काम करना होगा। और इस तरह के इनिशिएटिव्स जैसे आज SCL ने किया है, वो सभी संबंधित संस्थानों को लेने होंगे, मंत्रालय को लेने होंगे, CDAC को लेने होंगे, SCL को लेने होंगे, CDIL जैसी संस्थाएं हैं इनको लेने होंगे। और आप जो लोग मार्ग प्रशस्त कर सकते हैं, जिनको पुराना अनुभव है, जो इस फील्ड को जानते हैं, सेमीकंडक्टर मिशन को और कैसे प्रभावी बनाया जा सकता है, आपके विचार, आपके सुझाव, उनका स्वागत है। एकेडमिया का बहुत इम्पोर्टेंट रोल रहता है और हमारे प्रतिष्ठित संस्थानों ने हमेशा इसमें आगे बढ़ चढ़कर भाग लिया है। प्रोफेसर उदयन गांगुली यहाँ मौजूद हैं, स्पेशली IIT बॉम्बे से आए हैं, इनके साथ में मंत्रालय कई प्रोजेक्ट्स पे साथ में काम कर रहा है। तो मुझे उम्मीद है कि इसी तरह से एक चीज़ और बताना चाहूँगा कि जब हम IPs की बात कर रहे थे और प्रोफेसर कामाकोटी ने IIT चेन्नई में कहा कि उनका ऑलरेडी एक टाई अप है टूल्स के बारे में, तो क्यों नहीं हम लोग जो है उसको यूटिलाइज़ कर लेते हैं और सीडैक को यूटिलाइज़ कर लेते हैं। तो उस कार्यक्रम में भी देखिए मंत्रालय, सीडैक और IIT चेन्नई सब मिलकर साथ आए और हमने प्रयास किया है कि किस तरह से हम सुविधाएं जो टूल्स की हैं, IPs की हैं, वो आसानी से स्टार्टअप्स को उपलब्ध करा पाएँ। और ये मिला जुला प्रयास जो है एक बहुत अच्छा प्रयास मेरी नज़र में है और इसके निश्चित रूप से लाभ जो है सभी स्टार्टअप्स को मिलेंगे और जो आने वाले स्टार्टअप्स होंगे उनको भी मिलेंगे। तो हमारे पास ये एक स्वर्णिम अवसर है, एक सुनहरा अवसर है जिसका हमें सही उपयोग करना चाहिए और अपने आप को विश्व में स्थापित करना चाहिए। आज $820 बिलियन की जो इंडस्ट्री है 2028 तक, उसका ग्रोथ पाथ है $1 ट्रिलियन जो है वो 2030 तक हो जाएगा। और अगर उसमें 10% शेयर भारत अपना स्थापित कर पाता है आने वाले 4 साल में, 5 साल में, तो निश्चित रूप से हम ऊंचे पायदान पर खड़े होंगे और विश्व में नेतृत्व प्रदान करेंगे सेमीकंडक्टर में। जैसे आज की डेट में IT में माना जाता है कि भारत जो है एक लीडर कंट्री है, एक आगे बढ़ा हुआ देश है जो सबका मार्गदर्शन करता है, सबके लिए सुविधाएं उपलब्ध कराता है, प्रॉब्लम सॉल्विंग करता है, केवल अपने लिए नहीं, अपने देश के लिए नहीं, पूरे विश्व की प्रॉब्लम सॉल्विंग जो है वो इंडियन IT से होती है। तो इसी तरह से ऐसी ही रेजिलिएंट सप्लाई चेन की व्यवस्था हम सेमीकंडक्टर के फील्ड में कर पाएँ जिससे कि हमारा देश वहाँ भी उसी रूप में जाना जाए। यही मेरी कामना है, यही मेरी इच्छा है, यही मेरी आपसे प्रार्थना है, अनुरोध है कि हम सब मिलकर इसमें साथ काम करें। एक बार अंत में फिर से SCL को बहुत बहुत बधाई दूंगा इस तरह के प्रयास करने के लिए, कदम उठाने के लिए, और मुझे उम्मीद है कि दोनों का आपसी सहयोग, स्टार्टअप्स का और SCL में उपलब्ध टेक्नोलॉजी और सुविधाओं का आप सबका मार्ग प्रशस्त करेगा। बहुत बहुत धन्यवाद। जय हिंद।
सर, हम आपके सारगर्भित शब्दों और मार्गदर्शन के लिए बहुत बहुत धन्यवाद करते हैं और आशा करते हैं कि यही समय और सही समय पर यहाँ उपस्थित सभी स्टार्टअप इस अवसर का लाभ उठाएंगे और भारत को सेमीकंडक्टर के क्षेत्र में अग्रणी बनाएंगे।
Thank you, sir. We would like to express our deepest appreciation for Shri Bhuvnesh Kumar ji, who has encouraged everyone sitting here with his motivating words. And we would like to request Director General SCL to kindly present a token of gratitude to sir.
अब हम ED सीडैक श्री खनेजा जी से रिक्वेस्ट करते हैं कि वे जॉइंट सेक्रेटरी सुशील पाल जी का सम्मान करें।
As we come to the completion of inaugural ceremony of today's startup meet, we request our distinguished guest, Shri Bhuvnesh Kumar ji and Shri Sushil Pal ji, to kindly inaugurate the exhibits on SCL capabilities and offerings in the Kaksh exhibition hall. And I request all other guests and participants to kindly proceed for high tea and a refreshment break.
We will gather here again after exactly 20 minutes at 11:15 for the keynote address and technical presentation by SCL team. Thank you.
Please note that you have coupons in your registration kit that you are supposed to drop at a bowl in the dining area.
सर ठीक चल रहा है? चलो ठीक है। देख रहे हैं लोग कितने लोग हैं? मेन की छोटे वाले में? चलो 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 ये हो गया, TN एग्जीबिशन हो गया। अब यहाँ पे शुरू करेंगे।
अब टेक्निकल प्रेजेंटेशन है सर, टाइम ऑलरेडी Please take your seats.
कृपया अपना स्थान ग्रहण कर लें और आप सभी से अनुरोध है कि अपने मोबाइल फ़ोन को साइलेंट मोड में रख दें। वाधवा सर को एक लोग इधर आप उधर रहो, मैं बता रहा हूँ, एक कोई इधर रहे तो हमें बैलेंस मिल जाएगा ना। दीजिए सर,
छोड़ दो, छोड़ो, आप करो स्टार्ट। हाँ
सर स्टार्ट करो, आने दो। जलपान के बाद आप सभी का एक बार फिर से स्वागत है।
Moving on to the sessions of technical presentations by Team SCL, I would like to invite Shri Manoj Wadhwa ji to begin the session with first presentation on introduction and SCL offerings.
Manoj Wadhwa ji is having 37 years of experience in wafer fabrication and IC packaging, and currently he is working as a group head, project planning group, and manager fab upgradation. Sir, we welcome you to come to the podium and give the introductory lecture on SCL capabilities.
Yeah, good morning everyone. It's a great privilege and I'm really honored. Our first employee of SCL, Dr. M.J. Zarabi, is here amongst us. I just confirmed from him and he confirmed that he is the first employee who started SCL. They are our leaders and our gurus who really taught us how to work in SCL. And semiconductors was a new field for us. Okay, so what we'll do is we'll go through the brief presentation on what are the introduction part. Where is it? Yeah.
We have a separate question answer session post presentations.
Okay, so we'll have a separate QA session after the presentations. We will briefly go to the introduction. I think already many presentations have been done, where DG also and otherwise also. And maybe we will request Dr. Zarabi also to present something on the brief history of SCL. And we'll go through the design, fabrication, packaging, technology, ATMP, all the facilities, capabilities, what we have at SCL, right? So after the maybe presentation, we will have the QA session. So just giving the brief of SCL, as earlier also told, that we started our 4-inch fab in 1980s with a technology from AMI, USA, with 5 micron technology. And the good part was that we had R&D fab also. I think Dr. Singh has also joined. Yeah, he's here. Long life, sir. So we had a R&D fab at that moment, and wherein we developed in-house 3 micron and 2 micron technologies. And that was the creditable part, that there was no import of technologies at that moment, and we developed in-house all the technologies. After that, in 1997, we developed a new 6-inch fab that was for 1.2 micron technology, which was at that time developed at AMS Austria. And the whole process was ported from Austria at this moment, and a new 6-inch fab was put. In 2006, the name was transformed from Semiconductor Complex Limited to Semiconductor Laboratory, so under Department of Space. And that time, in 2010 and 11, we upgraded our fab and we put a 8-inch wafer fab, which was at 180 nanometer technology from Tower Semiconductor, Israel. And we kept some of the 6-inch equipment which are still being used for MEMS fabrication. And we developed many sensors starting from 2003 onwards. And now in 2022, again, we are back to Mighty as, we are now part of under Mighty leadership. And we are trying to upgrade this fab, and we're trying to augment. I think it was told by DG also, that we are expanding our fab capabilities, putting up new technologies like RF CMOS and CIS. I think technology part will be covered by Monica. And then we are also augmenting the fab capacity here. So as I think earlier also we have been telling that we are doing various domains, like we are doing VLSI, we are doing optical domains. In earlier fab also, in 6-inch fab and even in 4-inch fab, we have been doing CCDs. And we also started MEMS fabrication, so various sensors like pressure, temperature, humidity, accelerometers, gyroscopes, those have been done. And also various other technologies, ATMP is also there, and we have a complete screening and qualification line. We have around different IPs developed in our 8-inch fab, which is mostly at that time it was for ISRO. But now we are opening up and we are looking for startups to give some more IPs. We already worked with IIT Bombay, Udyan sir is here. And we developed OTP technology recently. And various IPs have been developed and given to ISRO, and various products also. One of the main product has been Vikram processor, which is now a workhorse for ISRO. And all the PSLV, GSLV flights are going with indigenous Vikram processor. And that's a big achievement because earlier we were totally depending on the imports. In addition to that, we are also supporting various institutes, around 119 institutes throughout India. We have MOUs, and we have been working along with C2S also. And the chip-in program is there, so we get many designs. And we run shuttle program. So as already Director Sir told, that we run a quarterly shuttle, almost a 1 quarter. So we get designs from various centers and startups. And then we also have indigenous design, our own designs. And we club them together in the shuttle program and then run them as a MPW program. We have a radar also by design. That radar cell library was developed because the technology what we got was not radar cells. So that was developed by our own team, design team. So design team will cover that part also. So we have 2 fabs. One is the 8-inch fab and other is the 6-inch fab. And 8-inch fab is for CMOS and the 6-inch fab is for MEMS sensors. So as seen that we are mainly earlier we were before shifting to Mighty, we were giving mainly to ISRO missions. So these are some of the devices which have actually flown on various ISRO missions like Aditya mission and other missions like Chandrayaan mission. CMOS camera configurator was the highlight in the Chandrayaan mission. There are other devices which are flown and they are all space qualified. One is the OceanSat, and recently in SSLV mission, various devices, I think that will also be covered. The RDS will be covered by my team. So these are some of the earlier projects done in 6-inch. Dr. Singh will remember Manas project we did for CERN experiment. And we did around more than 1 lakh pieces for those CERN experiment. And recently in 8-inch fab, we have done LDOs, which are 1.2 and 1.8 volt, and given to again for this CERN experiment. So these are 2 wafer fabs we have, as I earlier mentioned. One is the 8-inch wafer fab, which is at 180 nanometer technology node. And is already qualified as per JEDEC standards. And we do various other devices like charge coupled devices and clean rooms of various class. We have the cleanest class 1 clean room available here, and which is called the wafer start area where we actually start the wafers. And we have a MEMS fab where we do the sensors. So we do various sensors as I told earlier. And all these sensors have been developed and some are flown recently also. Accelerometer has been flown. We also help all the, if anybody wants like institutes or some academia, they want support for skill development. That also program we are running. We are also helping institutes to have interns. Around more than 800 interns have been trained at SCL, and regularly we are getting around 100 interns per annum. And we also did a training program for Micron. There was a requirement from Micron team for a utilities training program. That was also done. Some faculty development programs have also been taken up. So these are all the ways to support academia and the startups. If somebody wants, we are in touch with some other startups who want training for their students. So these are the various offerings for the startups. Like we start with the design. We have a good design team of around 30 designers, and we do various analog, digital. We are very strong in analog. I think that will come up in the design slides. And various mixed signal devices and MEMS, that also is being done. Then fabrication, as we mentioned, that CMOS, MEMS, CCDs and detectors, those are also being taken up. Then we have ATMP facility for ceramic packaging we have, and we are adding more capability for prototyping in the plastic package. So that is also being set up. I think soon it will be done. And we have a complete line for screening and qualification as per MIL standard. So we qualify as per the space requirement. So you can understand the quality and the reliability of those devices. I think next Mr. Rajesh Srivastava will take up. He will take up the design part now. Thank you.
Thank you, sir. Moving on to the next part of our presentation, me and my colleague, Mr. Asim Saeed, will cover the design part. So this slide shows the SCL design capabilities, means activities which are being pursued in design group is mentioned here. And we can, if you have any idea, this is for startups, if you have any idea in your mind, we can siliconize it. We can siliconize it. So if you have any idea in your mind, come to us, we will collaborate, we will discuss, and we can help you in siliconizing it, and SCL fabric can be used. So we can provide end-to-end solution, like means silicon, from concept to silicon. We can also do the feasibility analysis. Suppose you want to take any scheme from government and you want to develop something, we can have a collaborative effort and we can do the feasibility of that project. Welcome you all for this type of collaboration also. We can also do the end-to-end solution for analog and RF. Suppose you want to have any IP you want to design, and analog and RF team is very strong in SCL. They can give your help in the developing that IP, and the SCL fab can be utilized there. So in digital also we can have a full flow from synthesis to GDS. And memory designs, we have around 20 cuts of SPRAM and DPRAM, which are part of our offerings to the startups. And there are 20 cuts of SPRAM and DPRAM, and they are in 4 and 6 metal layers. So chip finishing is the last domain in design group, because we help academia institutes and startup for finishing their chip. Sometimes it happens that we are very good in designing, and when we design it, then we lost कि अब chip कैसे finish करनी है, pad कैसे लगाना है. So we help the academia and other institute for finishing the chip. We also develop in-house test chip based on our futuristic requirements. So these are the VLSI domain. Basically, we can categorize into 6 parts, which we have already covered in Vadhava sir's and director's lecture. So it can be categorized in analog, digital, mixed signal, and RF memory and imaging. So these are some products we have developed, like ADCs, Nyquist rate and oversample ADCs, DACs, and we have developed DAC around 200 megasample per second in 180 nanometer. That is a state of the art. So we have already developed, synchronized the DAC. We have also developed various varieties of LDOs, which can be used as an IP for any chip. Voltage supervision circuit is an essential part of microprocessors. We have a separate slide for processor. I will cover on the next slide. Digital domains, we have NAVIC baseband receivers and SADA ASIC and CHC control ASIC is also there. Multi-core RDAS, it will covered in details by my colleague. So I will left it for him. And it is a mixed signal type of design. And in RF also, we are developing LNA, VCO and mixer. For RAM, I have already covered that we have a synchronous as well as asynchronous RAMs with us, and dual port RAM 4K cross 8 RAMs is there. Imaging also we are collaborating with strategic sectors, and we are providing solution to them. Readout integrated circuit is an integral part of that. So this slide shows the various processors developed jointly with SCL and ISRO centers and academia. So everybody knows the name of Shakti. First it was developed and proven, Shakti code was proven first in India in SCL fab. After that they went to the external fab. So first code was proven by SCL backend team and the SCL fab. So, and it is freely available on Shakti website. You can download that code and you can make applications of using Shakti code. So these are different processors which we have developed. And Vikram, and you know that the name of Vikram also, it is developed for ISRO center, and it is the backbone of our PSLV, of the PSLV launch vehicle of ISRO. So as you know that for designing, PDK is essential part of any design team. So we can have a PDK, and we can give you PDK after signing the MOU with SCL, and you can use that PDK, and you can use that PDK to develop your products. So we are using industry standard EDA tools, and we supported by Cadence, Synopsys and Cogenda. So these are the basic things, and we will share this slide to you. So now I give my the presentation from here onwards. I give my this podium to Mr. Asim Saeed to cover the rest of the presentation. Thank you.
Thank you. So thank you, Rajesh ji. Let me start with the slide of the avionics miniaturization. So idea of showing you this slide is just to highlight that SCL is engaged in a lot of customization and indigenization activities for the users. One such example is shown over here. So on your left-hand side, you could see a telemetry package. It's an onboard telemetry package. It's a data acquisition package realized using high precision sigma delta ADCs, which are imported devices. A dozen of such boards are used, in the onboard telemetry system. One of the objectives of this avionics miniaturization activity was to reduce the size and weight of these packages, which is one of the key parameters for the onboard telemetry systems. So we have indigenized this imported chip. Along with that, we have placed 16 such numbers on a single die with on-chip signal conditioning and signal processing circuitry for all the channels, reducing the weight and size of the board, telemetry boards, by more than 50%. On the similar lines, we also have developed 3 more devices shown on the bottom side of the slide. There is octal core high frequency RDAS, quad core charge to voltage amplifier, and octal core LDO for the other, miniaturization of the other packages as well. 36 numbers of this multi-core RDAS, they are flown recently in SSLV and performed successfully. Apart from the SSLV, this device is also being used in the IVHM, that is Integrated Vehicle Health Monitoring System of the Gaganyaan, where it will acquire the parameters, environmental parameters of the crew module. Recently a 64 channel data acquisition system. It is a fully integrated system, a single chip solution for this whole board that is also been taken up at SCL. That is under development. So for the further reduction of these avionics packages as well. Recently we also have done plastic packaging of this device, reducing its footprint to 1/4 for the further reduction of the telemetry packages size and weight. It can be used in other various applications as well, multi-channel sensor signal conditioning applications as well. So the key takeaway of this slide is that with the indigenization and miniaturization, we can do a whole lot of optimization for the system available with the user. Now, another in-house development which we have done, there is ROICs, the readout integrated circuits for infrared imaging applications. Like a couple of examples are shown over here. On your top side, you could see an ROIC with the array size of 384 cross 288 with a pixel pitch of 15 micron and a full well capacity of 3.1 mega electron. Its advanced version with a bigger array size, that is 640 into 480, with anti-blooming and calibration features, that is also developed with a FPS of 56. Now, after covering these two devices, let me quickly come to the list of IPs which we are having. So we are having a lot of CMOS IPs. There are 16 such IPs which are commonly used blocks in various designs. So we are having microcontroller, RF LNA, a variety of LDOs, voltage references, instrumentation amplifier, LVDS transceiver receiver, along with a couple of temperature sensors and a recently developed 1.2 gigahertz PLL available in 180 nanometer CMOS technology. Apart from the CMOS IPs, we are also equipped with a variety of the MEMS IPs that include pressure sensor, accelerometer, and impact sensor of various ranges, along with acoustic sensor, micro heater, temperature sensor, and a recently developed thermal mass flow sensor. Now, after showing you the IPs which we are having, let me show you a slide for the IPs which we require from the startups. So these are mainly peripheral IPs. We need all these sort of IPs for the futuristic SoC requirements at SCL. So if any startup take the initiative to develop these IPs, will be highly interested. So they mainly cover communication interfaces IPs, display interfaces IPs, storage and wireless interfaces IPs. On the bottom side, you can see a GPS radio sonde system that is used to acquire the environmental parameter. This system is realized mainly using COTS component, which include LDO, charge pump, a couple of RF devices, PIC microcontroller, and ADC. So we are looking for part replacement for the system as well as the single chip solution for the system. In fact, ADC, which is shown over here, that is already developed and that is under testing. So probably in short time, we will replace the ADC of this radio sonde system. So before concluding my presentation, let me show you a brief video of the SCL design activities.
VLSI design activity in SCL is spread over the domains of analog, digital, mixed signal, power, memory, RF CMOS, optoelectronics, and radiation-hardened designs. Over the years, SCL Design Group has developed various designs in the form of application-specific integrated circuits, application-specific standard products, and system-on-chip, which have been fabricated, tested, qualified, and delivered for end use in critical applications. Design activity comprises of front-end and back-end stages. Each of them require expertise in multiple design domains and industry-standard EDA softwares for chip realization. SCL Design Umbrella comprises of data converters like Pipeline ADC, SAR ADC, Sigma Delta ADC, high-speed DAC, various flavors of LDOs, LVDS, readout integrated circuits, different configuration of SPRAM, DPRAM, LNA, PLL, and jointly developed processors based on SPARC, RISC-V architecture, and interface IPs. To ensure designs are traceable, secure, and safe, all project data are archived on Blade servers under specific project login. Reviews are inherent part of design cycle, and to maintain quality of design, reviews are undertaken at critical milestones before releasing the final GDS for mask data preparation. Reviews are inherent part of design cycle, and to maintain quality of design, reviews are undertaken at critical milestones before releasing the final GDS for mask data preparation. SCL designed and fabricated products and SX have been successfully inducted in various strategic sectors.
So that's all from my side. Now let me call upon Ms. Monica Gupta for the further presentation. Over to you, madam.
Thank you, Asim. So we have seen the devices which are designed, fabricated and delivered to various customers in the SCL 180 nanometer technology. So we'll look at the salient features of this technology. So this is the technology which we are working with in our 8-inch line. It is 180 nanometer process, and the starting substrate is the P-type bulk silicon wafer. There is no epi wafer in the core technology. And for isolation, it has shallow trenches, then retrograde wells. And in order to support two kinds of voltages on the similar area on the same chip, it has dual gate oxide, which are nitrided in nature. You can see the right side, there is a cross-section image which is taken in SCL SEM lab only, representing a gate, the silicided regions, the spacers, and the contacts, vias, and the shallow trenches. In the bottom image, we have a very well printed surface over which all the metals layers are printed on it. So in order to critically print these structures, we have two kind of mix and match photolithography process, which is deep UV 248 nanometer and MUV 365 nanometer for slightly less critical layers. And CMP is incorporated in both front end of line as well as in the back end of line. And in order to take care of the electromigration issues, all the metal interconnects have a protective layer of bottom titanitride. Aluminium is merged between top tinitride and bottom tinitride. And further enhance the printing of the very small features. In this technology, there is optical proximity corrections which are taken care during mass data preparation, and further then finally the dimensions which we have drawn are printed on the wafers. So the contacted transistor pitch in this case is 0.72 micrometer, which can be squeezed if we can reduce the contact size or the gate length if we want to slightly reduce it. And the left side is showing the top, bottom and the top cross section, including from the front end to the back end of the light completely. The baseline feature include 1.8 volt core CMOS with 1.8, 3.3 and 5 volt IOs enabled into it, and all these things are enabled into the PDK in a streamlined manner. The process is single poly and it takes from 4 metal to 6 metal with USG and FSG available for back end of line. So total process encompasses of 23 to 34 mask layer in this technology. If we look at the analog side, we have high VT transistors available where the leakage currents are one order less, so that in low power, low leakage devices it can be used. On the other hand, we have low VT transistors where it can be used for performance enhancement, and approximately 10 to 11% enhancement in the speed is seen in these devices. Then in back end of line, there is a very precision capacitor which is very linear in nature also, that is MIM capacitor, and have high breakdown voltages, and it has 3 different kind of density available, which is 1.7 and 2.8 femtofarad per micrometer square, and it can be stacked in order to double the capacitance density in the similar area, same area. Then we have buried well for isolation, substrate noise isolation. Then another important element is the high ohmic polyresistor of the sheet resistance of 1 kilo ohm and 2 kilo ohm per square, which is available in this analog modules. Then there is availability of thick metals. Other than standard metals, there are thick metals like 2 micron thick, 2.8 micron thick, which can be used for power buses and for RF modules also. Then there is a PDK available for 5 volt MOSFETs. And another important element which can be used as an OTP is E-polyfuse. This element is listed here because it does not use any mask. There is no change in the process and has a programming voltage of 4.5 volts. So these are the list of the devices which are available in SCL PDK, and they have all their SPICE models built into it. We have different MOSFETs, resistors, capacitor, transistors, diodes, and you can look at the design rule also, which are listed in the center table. Like the gate length is 0.18 micron and the spacing between two polylines is 0.25 micron. Similarly, all the lines and the spacings are listed in this. Another important element which is used by the designer is the native transistor. The NMOS native is also available, which can be utilized for further applications. If we look into the modeling of the devices which are available at SCL, other than the 180 nanometer standard devices, the SCL has ventured into the development of LDMOS also. It has been developed with the help of some academias and has been modeled in SCL up to 40 volt. We can see the characteristics of the simulated data and the characterized data. So what our fab supports is the maximum field size which can be printed is 22 mm by 22 mm. If we want to increase the size of the chip, then stitching capability is also there, which we are using in our CCD devices, which are bigger in size. And our average baseline defect density is around 0.05 defects per centimeter square. It means the process is very good in nature and low defectivity is there in the line. As sir also told, our fab is JDEC qualified, the process is qualified, and all the lifetimes for different process modules are quite high, and they are much higher than 11.4 years. This is the minimum requirement which is listed here as per its requirements. And the ESD it supports is 2 kilovolt human body model. Other than 180 nanometer process, SCL is working for other devices like detectors and different discrete devices also. So we have custom CCD image sensor process and detector process available in our 8-inch and 6-inch lines. Then the 1.2 micron CMOS, which was 5 volt process, which was earlier used in the 6-inch line, has been ported to 8-inch line and it's being used to deliver the devices for the railway chipset. Then we have one more detector available in the line, which is silicon photomultiplier used for detecting the gamma rays in the wavelength range of 500 to 600 nanometer. And now we are working towards the development of the blue enhanced SIPM. Then another important device which is taken up with the help of CDIL is the discrete BJT device available. We have achieved a breakdown voltage greater than 50 volt with the gain of 100 to 200. Now, in order to increase the voltage and retain the gain also, we are working towards the fine tuning of this device, and it will be available in a shorter time. So all the PDK, what are the processes and devices listed here, we have PDKs available for these devices and can be utilized by the academia or the startups. The right side is a reticle which is showing different chips together, put together in a multi-project wafer. If the size is bigger, then it will be a single chip. If the size is smaller, more chips can be accommodated in the same area. Since we have a very wide portfolio, we are looking for some of our technology IP requirements where we are slightly lagging behind. The one is RF CMOS technology PDK. It is more towards the PDK side because all the devices which are required for RF CMOS technology are already available in the SCL process. Then we are looking for high voltage LDMOS development where we are targeting the voltage ranges of 40 to 70 volt and higher gate voltages also from 5 to 10 to 20 voltages. Then another important field is the CMOS image sensor technology with low noise spin 3T and 4T photodiodes and different wavelength region, high to ranging low. And this we want in a format such that all the PDK which is developed for these technologies should be seamlessly incorporated into the SCL flow. This is the main requirement of these technology IPs. Here you can see the silicon detector portfolio which has been fabricated into SCL device and has been used for various missions. We have charge coupled devices for remote sensing, satellite orientation, X-ray detection. Then we have various kind of diode detectors for X-ray detection as well as charge particle detector ranging from small area to large area. Then strip detectors which are P plus in N type. Then SIPM as I told earlier also, and BJT. These are the devices which has been flown and the images have been captured by the ISRO. The 4K linear imager is flown into IMS-1. The 12K TDI is developed for cartography applications. Then we have our HISES for spectral CCDs and OCM flown into OceanSat. And we have area CCD for star sensing applications also. This is the timeline when we are starting a design, and once it is completed, then from GDS to prototype, how much time it takes in SCL fab. So once the DGS is received at SCL, generally it takes 2 weeks to compile all the data, because the data comes from different kind of users. It has to be compiled and then it has to be taped out as a single mask set. Once the mask data is done, then mask is received within 2 or 3 weeks time frame. Then the wafer fabrication starts, and it takes generally for the first prototyping to siliconize it from 15 to 17 weeks or 18 weeks maximum. And after that, the dicing is required, the testing on the wafer level as well testing of the packaging device is required. It all depends on the complexity of the device, and after that it can be used. I think this planner is already published on SCL website also. This is the typical timeline for a recent multi-product master which has been fabbed out recently. So you can look at the timeline. I think it is taking 18.6 weeks from T0 is active area start. It is a 4 metal process and having 25 masks in this process. This is another device which has been developed in SCL, the discrete BJT, in a very short span of time, and it took only 1 month or 5 weeks for the fabrication of this device, and its breakdown voltage is 50 volt, and we have ran another loop of experiment for this device, and we are able to achieve a breakdown voltage greater than 100 or 150 volt also. So the fabrication part of this presentation will be taken up by my colleague Mr. Amit Saxena.
Thank you, Monica ma'am. Namaskar. So coming 5 slides, I will talk about the SCL capability on fab side. So whatever you have listened till now regarding technology or design, those realized on the silicon by the fab. SCL fab is a kind of heart of IDM as a SCL. This is an industry standard fab which is in accordance with the ZEC standard ZP001. This is a 24/7 operational line. It has all essential requirements like infrastructure, equipment and manpower. All the clean rooms which is required for fabrication like class 1, class 10, class 100 or class 1000. We have all the classrooms for fabrication. Regarding the equipment side, we have industry standard equipments for all the processes, like for lithography, we have Nikon make equipment, whereas for CMP, thin film, dry etching, we have AMET based platform equipments. For diffusion, we have vertical furnaces from the TAL. And for the wet side, we have BLAM as well as semi-tool. So all these equipments are very industry standards and using in the various foundries outside the India. Regarding the manpower, this is the key strength for SCL. We have a very vast experience as well as a trained and experienced manpower to handle such kind of the processes. This fab is a it is producing a space grade product, all kind of like analog, digital, mixed signal, RF memories. So all kind of devices can be fabricated here with the space qualified. This entire SCL process having more than 650 process steps. So this is such a lengthy and complex process. To seamless operations, we have divided entire process into different bays to cater the diffusion processes like lithography processes, etching processes, implantation, thin film and CMP. Continuous monitoring and control is a key for a good fidelity device, and we are doing the same. We have a dedicated defect inspection line to check the inline defectivity while the processing of the wafer. This fab required raw material, which is specialized raw material, particularly for the chemical side. It is a very high purity chemicals where impurity levels are in the range of ppb, whereas the gases having more than 5N or 6N purity gases. This is the utility infrastructure having the SCL. This is the backbone for fab, continuous operation of the fab. Uninterrupted supply of these utilities make us to run 24/7 operations. Utility like each utility mentioned in the circle is required a full setup like DI water we are maintaining 18.2 mega ohm centimeter resistivity, which is the highest at the room temperature. Similarly, for electrical, we have established a droop system, which is for avoiding any power failure. Other systems like exhaust for removing the fumes, like vacuum system for handling of the wafers, CDA for different valve operations. So these, each utility has an independent setup. Safety is a paramount, and we have installed all the safety measures since we are using highly corrosive and toxic gases. So TGM, that is toxic gas monitoring, is installed there. Liquid leak detection system is installed there. Moving to another fab which is operative in SCL is a 6-inch fab line. Technology node is a 1.2 micron, but primarily we are using this fab for the MEMS application. This is a manual fab compared to the 8-inch fab, which is a automatic fab, automatic in a sense of equipment. Here loading is a manual, whereas in the 6-inch loading is through the SMIF, and the equipment takes care of everything. This fab we are also using as a R&D setup for our CMOS application, particularly where we can qualify the new raw material or indigenized raw material. This is another area where a startup can look regarding the raw material at India level. This fab, this 6-inch fab have all the equipment which are also industry standard and can take care bulk micro machining, surface micro machining operations for realizing the MEMS devices. As we see the lengthy process of fabrication, it cannot be done by manual ways. So industry standard softwares are required to run those fabs. SCL has developed in-house software for such application. We named it as Device Manufacturing Integrated System, or DMIS. This has feature like equipment management, process management, where we are monitoring all parameter related to equipment or the process. It has a module for a statistical process control, where those monitors related to equipment or process are analyzed through this statistical process control module. It has another feature for inventory module also. Right side images are just to show the front view or the screen of our software. This is a new software which is SCL is developing in collaboration with the CDEC Mohali. This is for defect automatic classification. Whatever the defect we have observed during the fabrication line, right now it is classified by the manually by the human being. That is a very time consuming method. So man hours can be reduced by this software. This is the automatic classification software, which is AI based, and machine learning techniques are used to do this. After implementing this, the time can be reduced in multiple folds by automatic classification. Right now, it is developed in a such way that 80% accuracy, it is working up to 80% accuracy. Further, we are trying to optimize this software by the teaching method, and our target is to reach the 90% accuracy. So before moving to
Wafer Fabrication Lab, called Fab, is the heart of SCL, and it houses a very clean environment. Fabs are designed as per international standards to process 8-inch wafer in 180 nanometer CMOS technology. There are around 450 processing steps for any CMOS device fabrication. Let's enter one of these clean rooms and take the breath of very clean air. Clean rooms are classified as class 1, 10, 100, 1000 or more, depending on the work being carried out inside. These are spread into an area of around 25,000 square feet, housing the fab lines. One can imagine the degree of cleanliness from the fact that the classroom 1 means there is not more than one particle of size 0.5 micron or more per cubic foot of air. It is virtually particle or contamination free. Highly specialized air filtering, precautions, and discipline is necessary to reach and maintain this level of cleanliness 24/7, as the fab never stops working. The fabrication process in 8-inch CMOS fab line comprises of diffusion, etching and cleaning, ion implantation, lithography, and metallization. The designs created by the engineering team are used to create mask. The patterns from the mask are then transferred onto the wafer by projection photolithographic process. The unprotected layers on the wafers are removed by plasma or wet etching. The dry etching uses gas precursors, while wet etching uses acids. Ion implantation technique is used to change the conductivity of the silicon substrate. Implanters of different energies are used for specific applications. Interconnections are carried out by multilayer deposition of dielectric and metal thin films.
This was the short video on fab operations. Now I would like to hand over podium to my colleague Sumit. He has a vast experience on ATMP processes. Thank you.
Thank you, Amit. Good afternoon, all. So we'll try to have an overview of ATMP facility at SCL. So basically, you can see on the left side our ATMP facility at SCL. In the center, we can see various equipment being used for assembly and packaging operations. And on the right, to maintain stringent quality requirements, we do have various, at various stages, we are making sure of the quality and with the support of all these equipment. We have a very good team of package design. We are doing package signal integrity, power integrity, thermal budgeting, all package design activities we are doing at SCL. These are the various outlines being offered for CMOS devices. We can see like from quad flat package, leadless chip carrier to dual flat package, various CMOS packaging outlines are being offered. We are also doing package on package and system in package activities. As we can see, 5-chip MCM module, multi-chip module we have done, 2-chip multi-chip module we have done, system package on package for memories we have done. On the right side, you can see plastic packaging. We are always committed towards miniaturization. So on the right side, you can see various plastic packages we have done. With the plastic package, actually we get a lot of like footprint reduction, weight reduction. So these are the benefits for the, so we are always committed towards plastic miniaturization. These are the various outlines we have offered and we have done so far for MEMS and optical devices. We can see we have done metal packages for pressure sensors. We have done ceramic packages for accelerometers. We have done metal packages for acoustic sensors and various kinds of packages we have done for various MEMS sensor. On the right side, you can see optical devices. We have done for various package development for charge coupled devices. We have done packaging for photodiodes, phototransistors in various COB configurations in metal packages. So in testing, of course, testing is a vital part of ATMP, so we are totally committed towards the complete characterization, post-silicon design validation of the devices being fabricated at SCL, and also from outside we do get for screening and qualification. So we have a complete facility for digital devices, mixed signal devices, analog ICs, RF CMOS devices. So these are the various equipment line what we have got at SCL. So like testing capabilities for rapid prototyping, we do have complete in-house capability of developing blade type probe cards, and for rapid prototyping for a small low pin count devices. And for high pin count devices, we do have design capability for epoxy probe cards. And we are doing all the test board design development at in-house at SCL. These are various equipment line what we have got at SCL for the various kinds of devices, digital, mixed signal, analog, all the devices, and temperature characterization. So all the equipment are there, and we are doing complete characterization of the devices. This is RF test facility. We are capable of doing up to 40 gigahertz at the wafer level. At the device level, we have got different equipment. We have got different configuration probes, all the wafer setups, and all we have got there. So this is the NAVIC receiver what my colleague already discussed about. So we have already done RF front-end development, Also, baseband development has been done, and will be soon doing this. Will be soon providing one chip solution towards this NAVIC receivers. And we are also committed towards medtech developments, and these are some of the developments. Most of the developments are already done or either at the trial stages. Like you can see, there is thermal flow sensor, bioimpedance sensor, then there is micro cantilever for glucose sensing. There are other like capacitive sensor, then there is pulse oximeter we have done. This is complete development has been done. So, like you know, there is a high demand of high voltage devices. So we have established our test setup for high voltage and high power devices, like for GaN devices. And then we will be soon augmenting our wafer probing capability from 8-inch to 12-inch. And we are always committed towards open cavity plastic miniaturization packages with the augmentation of, as of now, we are having aluminum wire bonding. We will be soon upgrading to and augmenting our facility with gold wire bonding and plastic packaging facility. So this is our complete offering towards assembly and test operations. Like we are doing complete test program developments at the wafer and device level. We are doing post silicon validation, complete characterization, in addition to like additional requirements for testing, like radiation testing, screening and qualification. Then we are doing package modeling, package design, complete like ceramic line we have got, and will be soon augmenting plastic line. And then this complete assembly line is there. So we have done various custom package developments. So it's a complete offering towards ATMP we are doing there. So we'll have a short video towards our assembly and.
SCL has capability for assembly and packaging of high reliability CMOS, optical and MEMS devices. Facility is housed in a 5,500 square feet area with class 1000 and 10,000 clean rooms and class 100 laminar flow workstations. Post fabrication, tested wafers come to assembly with wafer map. Package selection and process identification is done based on end application requirements. Packaging operation begins with die singulation. SCL has mechanical saw for dicing up to the size of 12-inch wafer. Diced wafer is expanded to increase die separation. From diced wafer, dies are picked as per wafer map and attached in package using epoxy adhesive. Electrical connection of die to package is done using aluminum wires by ultrasonic wire bonding technique. Then these packages are hermetically sealed using metal lids and solder material in dry nitrogen environment. After sealing, device identification on these packages is done using laser marking, followed by trimming and forming operations as required for packages with leads. Ceramic packages in various outlines like CQFJ, CQFP, CPGA and CQFN are used for different devices to meet functional and assembly requirements. SCL also has capability for custom package development.
We have a short video for testing.
At VLSI Test Division, post-silicon validation and characterization is carried out. To support test activities and quick prototyping, test hardware boards are designed in-house using CAD tool. This comprises of hardware development for electrical characterization as well as screening and qualification like burn-in boards. To accommodate testing of high pad density devices, SCL specializes in development of high pin count epoxy-based probe cards. Wafer probing is carried out to select known good dies, KGDs. Tested wafers along with wafer sort map are transferred to packaging division for assembly and packaging. Depending upon the device type, analog, digital, mixed signal, memory, RF and optical, test setup for testing can be benchtop or ATE based. After receiving packaged devices, validation and characterization is performed for full functionality of device over required operating voltage and temperature ranges. SCL also has facility for characterization of RF and high power devices. In-house 3D printing facility is used to develop fixtures and carriers for device testing.
I'll request my colleague Preetika to please carry forward the presentation further.
Thank you so much, sir. To ensure that the delivered products, they meet the global standards of quality and the reliability requirements of strategic sectors, SCL believes in building the quality at every stage of product realization, be it design, fabrication, assembly, testing, packaging, or screening or qualification. Yes, that means quality assurance from concept to delivery. At design, the quality assessment is done at 3 critical stages, that is design feasibility, pre-layout, that is schematic or at synthesis level, and at post-layout level. On fabrication, the fab is entirely qualified as per JDEC standards, JP001A, and the quality systems as per MIL PRF requirements are well in place. As and when the process upgradation or process tunings are done, the process qualification test with respect to reliability issues are done using state-of-the-art reliability test systems. On the similar line in assembly, testing, and packaging as well, we have military standard 883 specified quality systems, and all the packaging process is inline audited. The test plans, the test reports, the data packs are thoroughly reviewed by the team of experts. Moving to screening and qualification, the requirements defined by the universal standards, the all test requirements, basically categorized into 5 broad categories. All such equipments are available in SCL under single roof, be it environmental test covering thermal cycling, thermal shocks, or mechanical test like mechanical shock, sine vibration, constant accelerations. All the systems are available there in the SCL, and we follow the entire screening and qualification plans as defined in the military standards. We also have the capability to perform pin testing, ESD testing. To meet the special requirements of space, we have the capability to do total ionization dose testing and as well as single event effect upsets also. A dedicated FA facility is available in SCL as the process requires continuous monitoring for yield enhancements and for defect reduction. So for that, SCL offers electrical FA, electrical failure analysis capability, as well as physical failure analysis capability. In electrical FA, we have like state-of-the-art equipments like photon emission microscope, packed with laser stimulation techniques like TIVA, double-sided probers. And to support the sample preparation, we have the facility for reactive ionizer, microcleavers, and focused ion beam, which is integrated part of scanning electron microscope. And to check the composition of the defects, we have the energy dispersive X-ray systems as well. So we'll just present a short video of the facilities at SCL before moving ahead.
SCL houses facility for reliability testing, screening and qualification, and failure analysis of VLSI devices as per global standards. It has capability to perform process qualification by reliability testing for failure mechanisms like electromigration, hot carrier integrity, dielectrics, metal insulator, and metal capacitors as per JDEC standards. SCL is competent to perform screening and qualification of products as per military standard 883 and houses live operating test system, thermal cycling machines, thermal shock chambers, vibration test system, PIND tester, mechanical shock system, constant accelerator machine, and many more. To continuously improve its products and processes and ensure reliability and excellence, SCL has failure analysis facility. Failure analysis in microelectronics is complex and challenging tasks as it requires localizing defects typically in sub-micron range. So localization techniques are tailored case to case. In addition to optical inspection capabilities of up to 1500 times magnification, SCL is equipped with state-of-the-art fault localization techniques as photon emission microscopy and thermal laser simulation techniques. These techniques are good enough to localize faults in current technology. Cases where metal layers block emissions, backside milling tools are used for die thinning up to 100 to 200 micron and locate fault. Further, physical analysis is conducted using delayering tools like the reactive ion etcher and grinder polisher. And each layer can be inspected using scanning electron microscope with a resolution of 10 nanometer, coupled with focused ion beam for precise cross-sectional inspection and energy dispersive X-ray analysis to determine composition of defects.
Now I would like to call upon Ms. Meetu Arora to take the presentation further.
Thank you, Pritika. Namaskar. Indian semiconductor sector currently has high dependence on the imported materials, whether it's a equipment, wafer, chemical, or a gas, etc. Thus, it's a high time for Indian startups to endeavor into indigenization of semiconductor-related materials and machinery. At SCL, for wafer fabrication, 35 numbers of different ultra-pure chemicals and 25 numbers of high-purity gases are being used. Based on their chemical nature, the 35 numbers of chemicals can be categorized into 6 categories as shown. Semi-recommended grade 4 chemicals in use at SCL are ultra-pure with trace impurities level as low as 0.1 parts per billion. With SCL hand-holding, collaboration with academia and industry partners, formulation of 10 such chemicals have been finalized with their test results validated by short loop experimentation and are ready for production. With the expected growth in semiconductor industry, the consumption volumes of these indigenized raw materials are expected to increase many folds. Challenges faced during indigenization of these chemicals include undisclosed formulations and purification methods, cost-intensive infrastructure for manufacturing, testing, qualification, and packaging of indigenously developed ultra-pure raw materials. These are the few ultra-pure chemicals spares which were indigenously developed with by SCL in collaboration with Indian academia and industry partners. Another pressing issue having huge market potential for startups is the disposal of semiconductor industry waste, typically of hazardous and toxic in nature. Innovative, cost-effective, eco-friendly, sustainable, and regulatory compliant chemical and heavy metal recovery systems, water reclaim systems, gas abatement system, especially dry scrubbers, will be in great demand with the expected growth of semiconductor industry in India. Some of the real-time challenges faced by SCL include cost-effective methodology to reclaim QC and rejected wafers, spares and service support of equipments, disposal of metal targets, media of dry scrubbers, arc lamps, etc., authorized facilities for decontamination of toxic gas cylinders before their disposal, DISS and CGA valved cylinders and their filling within India, Indian semiconductor standards, and the calibration facilities for high-end analyzers within the country. Thus, there are substantial opportunities for local vendors to venture into these relevant fields to provide cost-effective solutions to semiconductor industry in India. SCL has also taken a few initiatives towards environment protection, water and energy conservation. Energy conservation is achieved by integrated green energy with the replacement of conventional lamps with LED lamps, use of energy efficient motors and incorporation of variable frequency drives for motive loads. Water conservation is realized by reclaiming good quality water during fab low production or no production hours, which is used for non-critical applications like wet scrubbers and cooling towers. Further, a part of the treated water of ETP is reused for watering of lawns at SCL. With this, I request Shri Deep Sehgal of VLSI Design Division to summarize and conclude this presentation. Over to you, sir.
Thank you, Meetu. Good afternoon to all. Now, my colleagues have already presented to you the facilities, the capabilities which SCL is having as an IDM. And almost we have come the full circle. It is time why we are here basically. We want to say that how we can meaningfully collaborate, how we can meaningfully connect. For what? To bring out some SOCs, some products, loaded maybe in the 180 nanometer of our own country, and to come out with the good products because you are so close to the market. You know the realities of the world. And this is the time when we want to give you a summary of what all we have gone through. And there are possible lateral entries almost in all domains of SCL. For example, design, technology, fabrication, testing, packaging, screening and qualification, almost all there. And our facilities are open to you. For example, if I summarize the slide in front of you, the design side says that there are certain IPs to give, mainly analog centric, as you were listening in the morning, voltage references, ADCs, LDOs, but there are certain IPs which we are not having. And we require those IPs, and you know they are the integral part of any SOCs, meaningful SOCs. They are mainly peripheral IPs which are possible in 180 nanometer. Apart from this, there are design service options already open which we are doing with our end centers, strategic end centers, RTL to GDS, physical implementation to GDS, synthesis to GDS, like that. And there can be possible other joint activities. PDKs and base IPs are anyhow already available on our portal, and it can be anytime shared with you, not only PDKs but base IPs, foundational IPs also. That means libraries, memory cards and IO-cell libraries. Coming to the technology side, yes, there is a baseline flavor available with us with the IIT Bombay putting the NVM the OTP capabilities on it, but there are yet more to do. For example, when we were highlighting, we were saying that we need RF CMOS modeling, we need HV-LDMOS, and we also need the CMOS image sensor technology. At least these three flavors on the baseline CMOS technology. Coming to the fabrication side, MPW, multi-project wafer runs, as you know, it is the industry practice, but not one. If your test chip fails, for example, you can have a second option of going to the test chip, and it can be a negotiable arrangement. And that is one of the crux where we can put a spot for you, as highlighted in the DG Sir's slide in the morning also, that we can reserve a spot for you where you can come, you can put your design, and it will be fabricated in 180 nanometer. On the testing side, post fabrication, as my colleague Sumit has already presented to you all the capabilities, the RF, the high voltage, the thermal cycling and the chambers available, and it is all open. Die packaging side also, we have a custom designs, and we can also offer you the packaging, maybe in the ceramic, in the plastic. And also on the screening, and we can go for the screening and qualification, the failure analysis. We can also go for you see the initial level of screening or the initial level of qualifications, which we are regularly doing for our highly reliable aerospace and the other space departments of our country. So this is where we stand today, and this is what we are looking with the startups which are sitting in the audience, the esteemed ones, our own ones, and you have a mindset to do something. So please try to make this more meaningful engagements in the B2B discussions, which we'll be having very shortly. Now I will be taking you through the virtual tour of the fab, and thereafter we'll be opening for the Q&A sessions. Thank you.
क्वेश्चन आंसर सेशन के लिए हम आमंत्रित करना चाहते हैं डॉक्टर बी उमापति फ्रॉम प्रोसेस टेक्नोलॉजी ग्रुप से,
श्री मनोज वाधवा जी को प्रोजेक्ट प्लानिंग ग्रुप से,
मिस्टर सुधीर ठाकुर EFTG ग्रुप से,
श्री सुदीप्तो दास गुप्ता जी फ्रॉम CCD टेक्नोलॉजी,
मिस्टर संजीव लूथरा फ्रॉम फैसिलिटीज़,
and Mr. Krishan Kumar sir from packaging division.
मिस्टर दीप सहगल फ्रॉम VLSI डिवीजन। आप क्वेश्चन आंसर कर सकते हैं एक्सपर्ट से।
So we have panel of experts here from SCL. So those who have any queries, they can ask questions.
Hello. Once we received the PDK, so 5-volt devices, primitive, all are coming in the same PDK package. 5-volt basically.
PDK.
Hi, yes. 5 वोल्ट का, 3.3 वोल्ट का, 1.8 वोल्ट का सारे के सारे डिवाइसेस एक ही पीडीके का इंटीग्रल पार्ट हैं, विच इज़ वर्जन 3.0, जो अभी हमारे प्रोजेक्ट प्लानिंग ग्रुप से आप ले सकते हैं। यस, यू आर राइट, 5 वोल्ट उसी के अंदर है, आईओस भी उसमें है, 5 वोल्ट के आईओस भी उसमें है जी।
Okay, my second question is LD MOS sites. It's a 15 volt LD MOS available. 15 volt LD MOS.
Yeah, it is available. It is available, and we have a models for that. But only thing is, it is yet to be integrated into our standard PDK. So, however, we can take up some custom-based high voltage circuits for specific users. So once it is integrated into PDK, it will be available to all for standard EDA tool design.
So what is the gate voltage for that?
So we have both 3.3 volts is gate voltage. VGS is 3.3 volts, and VDS is you can have 15 volts. 5 volts is also there from VGS 5 volts. Yeah, VGS 5 volts is also there, and both VGS 3.3 as well as 5 volts both are available.
Hello, this is Narahari from Semiconductors, Bangalore. First of all, a huge applause to SCL team. So because the secretary of METI has told that the culture of SCL has to change, and this is a visible proof. I think we need to give a standing ovation all of the 30 startups about how the culture is changing.
Thanks for your support.
And second thing, on the we have, so if SCL has to be India's TSMC, right? So TSMC has got a TSMC online. SCL has to have an SCL online, and all the 30 startups need to get access to the SCL online. And second thing is, we have the first reference flow, TSMC 1.0, 2.0, 3. We need a SCL reference flow. So the startups can also help in putting together the SCL reference flow.
Sure, sir. We will take this into account. Just keep on noting, sir.
Sir, going the online, if you will visit the recent website of SCL, there is a huge lot of information which has been placed in the recent regime, and it carries even the all types of flavors, like the first question, 5 volt IOs, even the combination of 1.8, 3.3 volt, all those combinations very much visible, memory cuts visible. Reference flows, yes, we have our own industry standard reference flows, but we have to once sit with the EDA community also, and to bring out it in the cross-domain reference flows. I think you are meaning that.
Yeah.
Surely, we will take it up.
Yeah.
Thank you.
Hello everyone, this is Jay from Nemada Industries. I read that earlier a lot of IP requirements were listed, namely USB 2.0, SATA 1.0A, Wi-Fi, Bluetooth, and I wanted to know that if any startup which wishes to work on these and take an initiative, what kind of support SCL gives them, and what kind of collaboration is that? Is that a contractual based collaboration? Is that a MOU, or do we share the IP rights, or is it flexible?
It's flexible. So we can work with, depending on what startup capabilities are there, We can work with MOU base also, and it's a project base also. We have worked with the IIT Bombay, and different forms are there for IP sharing, right? So it can be one-time IP sharing cost, or it can be based on the number of wafers produced. So that can be worked out.
And how do we?
Discussing
Yeah, we were just discussing. in the break.
in fact, this is a good opportunity for you to apply under the DLI scheme. So we'll be able to fund you. I can give you all the details. We'll be able to fund the development with this understanding that those IPs will be consumed by SCL in their 180 nanometers. And as he said, I mean, this could be on a royalty basis. The payments could then be worked out between you and SCL directly. So we can fund the development. We can give you access to the tools. We can provide all support. So that will be, I think, a win-win situation for both you and SCL.
So that was the idea of this meet, that we offer what we have, and we want some IPs so the startups can develop those IPs and give it to us.
Hello, sir. So, question from here. This is Syed Akbar from Craftronics. I have a couple of questions. One thing is with respect to the EDA flow, especially what Deep Sir was saying. So, first thing is, does SCL has their own specific EDA PDK team separately identified? Because especially that is the important part. That is one critical piece which I have been looking at from a past background from the EDA. So if the PDK team is independently set up, which can support the community of startups at the same time the EDA team, that is need they are. We should have a dedicated PDK team, because we have been in the past, we have been discussing on developing the flows and the specific views for the specific flows and everything, because one of my team member also has enhanced, specifically addressed that point. That's the first question. And the second question is with respect to the offerings of 180 nanometer for the business point of view. Is there any specific white paper which you can publish specifically if the startup community or the industry community should look at SCL as go-to foundry for 180 nanometer process? How does it stand with the industry global players, right? Specifically, if you talk about TSMC 180 nanometer offerings, anybody else, and where do you stand with respect to commercials, with respect to the quality, with respect to delivery timelines? If there any white paper has been published, if it can be published, will be a very good starting point, at least a reference for everybody, that we know that, okay, if we go here, this is what is the results coming out. If we go here, this is the cost, this is what is going to happen, what are the differences, and all these kind of aspects, right? If the white paper can be published, it will be a great help for the community here to consider.
Okay, your first question I will take up first. This is related to the EDA and the PDK team, correct? So yes, we are having a small PDK team which is doing the PDK work and which is coming up with the new solutions. For example, for a very recent case I will give you, Caliber is a sign-off tool, and we all know that Caliber is an industry-wide sign-off tool for the physical verifications and for the parasitic extractions. But to include, we have also included now the cadence tools. For example, the Pegasus tool and also the QRC tool. So we are broadening our portfolio actually, and this all has been done internally with a very less cadence support, but we can have a more support in the days to come, and we can even broaden our PDK to the synopsis also. For example, the star RC. So one by one, we are increasing this content internally. This is all in-house development, and now it is released also. Beta version 3.0 to the community, even the academia in the C2S program. So PDK team is there. Maybe in the days to come, when the business will be growing too much, we'll be having need to have a dedicated set of PDK team. You're right. Coming to your second point, TSMC, and maybe I would like Umapati sir or maybe Manoj sir to take up this question. Thank you.
It's a valid question. I think we have been discussing with the C2S team also, because this is a pilot line what we have, right? This fabrication line was mostly done for ISRO. But now we are commercializing it, and we are going to add more tools in this line. And soon, I think the expansion of this line will happen. And we ensure that we will not exactly meeting, okay, TSMC is a big production house, right? They have number of equipment in the line of similar kind. So to some extent, okay, we'll target to reduce the cycle time and try to meet those targets, okay. And it will take another few months, and then we will be able to add more equipment in the line to match those targets. You are correct. We'll make some white paper also, that what are capabilities, what we have here, and where we go to expand, where we want to expand and show our capabilities and reach our targets. That also will be published there. We'll take that in mind. Yes, sir. So you should be answering the question.
Yeah. No. I just wanted to pay my compliments to all of you, great SCL team, for having moved it forward over the years since I left up on superannuation. Once again, my congratulations to you all.
Thank
and
you.
my
Thank
compliments
you. Needs your encouragement.
for arranging this event. I think this is a good start. While sitting here, I had just jotted down only one question. I think it's more addressed to Deep Saigal. I'll read it out as I had jotted it down. I said, notwithstanding the challenges that will be faced, can we take courage to undertake design of our own SoC using Vega processor core for a truly indigenous tablet and even for smartphone and IoT hardware? And I am talking of equivalent of, say, MediaTek MT8766 that I recently looked at the data sheet of. That was a question. You needn't answer it now. I think it's more like,
Sir,
enthusing ourselves. And I also wanted to, I was telling Bhunesh Kumar ji just before our tea session, that I was almost on the verge of winding up my second innings, but I am sufficiently enthused to start a third innings, and I might start up myself. And if you guys don't come up with this equivalent of 8766, then I think I'll put together a team and start working on that associate.
Sir, just like your enthusiasm. Okay. Sir, you please come here.
Sir, we have already taken the courage, and we will be having the first SoC going for MPW with Vega.
Let me just introduce you. So he's Sridharan Mani. So he's one of the startups that we have incubated under the DLI programs, who is using Vega processor. In fact, there are two who have been incubated. One who is doing a POSIT accelerator along with Vega, and they are the one who are doing GPON. He is based out of Chennai, sir.
Based out of Chennai, sir. Based in Chennai. So we are having the first SoC with Vega. Please, sir, we'll love to. Yeah, absolutely. I'll try my best.
So, sir, very humbly, I am putting it across that what your question you have raised. Yes, we are actually here for a very meaningful purpose, sir, and we are targeted to develop the SoCs, actually SoCs, but may not be Vega based, but it will be Shakti based, anyhow Indian owned processor, any processor. And we are doing some work which we cannot maybe right now disclose. A big SoC is coming up, sir, and very soon probably we will be having something on this. But very humbly I am putting it that yes, we are targeted for that.
I said Vega because I thought they have the entire ecosystem. I have not read about Shakti's availability of the entire ecosystem. It is there. Good enough, I think. I was kind of involved in both when we approved these projects of CDAC for Vega and Shakti for Hyderabad.
Yes, sir.
So, thank you everyone for this presentation. I am Dr. Dheeraj Kumar Mahajan. I am Associate Professor at IIT Ropar, and I have a startup called Body Loop Labs. So we are developing Class C devices which basically goes inside the body and relay the body information on mobile phone. So in this case, my requirement is not the chip, but a micro sensor which is of MEMS size. And in this case, we also need flexibility in these sensors. So I'm new to electronics, truly speaking, but I am good in manufacturing and all. So my question is, do we have capability of flexible sensor manufacturing at SCL? And as a startup, if I want to integrate with SCL, from where I should start?
Somebody from you can answer. Rahul, would you like to answer?
So we have our expert at the outside.
Sachin Sharma.
We have done, you are very close to us anyway.
Yeah.
You can come anytime and meet us. We have done some flexible electronics. Sensor is so small that it cannot be flexible, right? It's a silicon, so
completely.
it has to be on a flexible substrate. So that we have already demonstrated in the exhibition. I don't know if you've seen. We have done a radio sonde, which has a flexible electronics PCB on it. So that facility is also available, and we can work with you if you have specific sensors. Of course, we have the capability.
Okay, sir. Okay.
Yes, sir.
I'm Sanjay Moghe, CEO of RFIC Solutions. I have worked in USA for more than 40 years. Of those 15 years, we have developed RF chips in India. We have IP of about 300 chips for all kinds of RF applications that we have developed in India over the last 15 years. And a lot of the IPs that you mentioned, we are very interested in seeing if we can convert those chips into some of the IPs you're looking for. Some of them, so I'm very eager to talk to your team and see how we can submit to DLI. A lot of these chips have been developed already in India. We have been doing it for a lot of companies out of India, because very few chip companies in India gave us contracts, but we got some contracts from Tata and Tejas Networks and some of those, so we have done some work for them. But I'm very glad to see that you are looking at IPs that probably number of startups could provide, so we are very interested in that. So if I can meet with you later on and talk about how we can,
Sure, sir.
if you have lots of IPs that are really available from, like TSMC or other foundries have a lot of IPs that are available, so then more complex chips can be made very easily, because you just pick LDOs, DROs, whatever parts are there. So a lot of startups can provide IPs, so that the ecosystem for building these complex chips is all there in India. Currently it is not there, but you're taking the step in the right direction. So I'm glad to see that list. And how can you expand it so you can become like, so many complex, building block cells are available through your IP system, that anybody can build very complex system by basically picking all these parts and putting it together. So something like that can really make your fab very useful. So are there any steps in that direction that you're taking?
Sure, sir.
And we are of course very interested in working with you.
Maybe we can have B2B discussion. We have some timing kept, and RF is domain of our director also. He is very keen on this. So we can have one-to-one discussion with him during the B2B. From 2 to 3 p.m. we have a separate session. I think we can discuss, and our CDEC team can also join.
Thank you very much.
Right.
Hi sir, so I'm Nicole from Indisamic. My main question is that you mentioned that you're looking for a lot of IPs, right? Like CAN bus, PCI, etc. So is it possible that we will provide you the RTL file of FPGA proven RTL file, and you can help to create the RTL to GDS, and then we can validate those silicon IPs, and then we can submit those flip chip type or wire bonding type wafers to the startups, where they can connect multiple IPs into one SIP. So new OSATs that are coming into the Indian market might be useful for the future startups or the companies.
Yeah, fine. Indisemic, we agree with you that you are having IPs, you are having validated IPs, RTLs which are validated on FPGAs, and you need it to be converted to the silicon through RTL to GDS route. Yes, we are very much open. We showed in our slides also that we are taking this type of services very much on the strategic sector units. So yes, yeah.
So sir, just a quick thing that the timeline.
Sorry, just a second.
You brought up an excellent question, and he gave a beautiful answer, but it also creates an opportunity for the ecosystem.
Exactly, sir.
Because if you have the RTL, they can make it at the fab. There are a lot of people who are here in the audience who can help with the RTL to GDS2. There are academic institutions which have actually done C2S, taken a chip RTL to GDS2 on the flow which belongs to SCL. So this is an opportunity for a service sector startup to also come up. And that service sector startup can come out of an academic institution having made a chip at the academic institution, but having gone through the flow, it has experience and has written extra scripts to stitch all the tools together to make it into a unified flow. If you've done RTL to GDS2, I suppose you know what I'm talking about.
Yes, yes.
So that's an opportunity space even for other people who neither have an IP nor have a plan to make a full chip, but want to play in the ecosystem. So we have people like you providing the wanting to make IPs. There might be people coming out of academies or other places who can actually do a full chip. These RTL to GDS2 flow part. And even if there's a startup which is doing a full chip but has manpower, they can also get into the service sector for this activity.
Correct. Because the main thing
yes.
is...
so we can have that kind of activities in there.
Definitely,
Excellent
sir.
point.
Yeah. Thank you so much. Because my main question is that to add into my previous question that we have to move fast because world is moving very fast. So if we want to do a silicon validation and all, so the fabrication and everything would be in just I think in the previous session we have mentioned that in 1 month if we provide something validated diced wafer to the startups or the wire bonded SIP in 2 months, then it would be great for all of us to create the ecosystem where we can use SCL Chandigarh fully. Yeah.
Sorry to interrupt, but we'll have only 1 or 2 more questions, and rest of the discussions can be done in detail in B2B meetings. Last 2 questions. Yeah.
Hi, I'm Shashank Kumar from Multi-Nanosense. So adding on to the conversation that was happening right now. So we are very good on the materials and the sensing part of things. What we lack or the expertise that I saw today on the presentation is getting all of these other peripheral electronics onto the same chip and make an SoC. And similar sort of question that came from the back is if those IPs can come here, if those stuff can be put besides our sensor, then we have a product which can be mill grade that you guys can any which ways do and the auto grade, and we have customers. So the entire thing comes a full circle and we are already exporting and doing stuff like that. So I think getting to this is the most important part. How can we accelerate all of this?
So we already have done, I think we have shown in the exhibition also. We have done many IPs together in single package, in single chip. All kind of integrations are possible. And if you bring a design level, so we can take it up. That's not a big deal. Sensor and electronics integration with signal conditioning, that also has been done. So currently we also, I think we have not declared somewhere, we are also doing where we have ROIC and the sensor built over it on the same substrate. So that also integration has also been done.
Hi. Good afternoon. This is Anirudh, me and my friend. We are here from Selectric. We are into compound semiconductor manufacturing, fab for that, and we are wondering if SCL we can do some collaboration in terms of the R&D on the device side. It's going to be an integrated fab, right from wafer to devices. If on in one of the presentations we heard about compound R&D that SCL is into. If we can collaborate on that, as well as there's a wealth of expertise in SCL in terms of operating and running fabs infrastructure. So we are wondering if some kind of a collaboration on that front is also possible with SCL. So it would be nice to hear.
Actually, we started working on GaN and gas-based devices earlier, thinking of 6-inch fab line to make devices once we have epitaxy done. So since GaN and gas are there are cross-contamination issues associated with these technologies, and even to do meaningful R&D without facing these cross-contamination issues, we need to have a dedicated tool setup in order to progress fast. So we already mentioned that the tool set which we have for 6-inch device fabrication line is too less to make a device, whereas the GaN and gas-based tools which we are having is also not complete in that manner. So now we are concentrating to do some sort of epitaxy, so we can work together to build device quality epitaxial layers, and we can, once we have a dedicated fab or whoever has a dedicated fab elsewhere, we can supply the epitaxial wafers for fabricating devices on those things. But at present, our main focus, or SCL being CMOS right from the beginning. So most of the workforce are familiar with CMOS operation, knowledge on CMOS, on silicon-based devices and materials. So GaN and gas, we just started, but there is a long way to go. Presently, as I said, we are limited to working together to develop epitaxial layers using the existing facilities of MOCVD, provided somebody can help us also in that.
Got it. So we do have some expertise in epitaxy, so we can see if we can work together,
yeah, we can
and we can find some synergies.
Yes.
We'll be very welcome to that.
Yes, okay.
Yeah.
आप सभी का बहुत बहुत धन्यवाद. और क्वेश्चंस को हम B2B सेशन में भी ले सकते हैं. सर want to ask a question. Yeah.
See, just wanted to, in fact, I'm sorry that I could not come. Abhishek Singh, Additional Secretary MeitY. I was supposed to come in the morning session, but I was in an event at AIMS, so that delayed me. But I was listening to the presentation and the capabilities of SCL, and 2 months back I was fortunate enough to get to visit SCL Mohali and see the capabilities that they are there. So SCL was set up long back, and we have had luminaries who are here. We all know what potential it could have had, but never too late, and the way they are planning to kind of leverage the whole ecosystem under the semiconductor mission, SCL can be a big enabler. So the facilities are there, and the government is committed to kind of further augment it. So it's very nice that SCL has organized this interaction meet with startups, because you are the builders who will build the solutions. SCL and government will just enable it, and the value that will be created will be much more immense. So I would call upon you to please let us know what more SCL needs to do, but at the same time get to know what is there, and try to use as much of the facilities, as much of the tools, as much of the machines, as much of the expertise which is there. Amongst all of them, they have solutions to all. But if we get to know what more needs to be done, then maybe together with the semiconductor mission, we can try to fill those gaps. Yes, and that is where we will be able to add value to our electronic story, our semiconductor story. And so already investments are being made. But in the next 5 to 10 years, we will emerge as a very strong semiconductor nation, and SCL and all of you play a big role to you. So for me, it was more like of an enlightening session. I handle other subjects in MeitY. I've been handling Digital India, and now I am handling artificial intelligence, cyber security. But whatever we do is ultimately depends on the chips that you make. So look forward to hearing more of the partnership that you are building starting today, and in the days to come we'll take it to greater heights. Thank you for having me.
Thank you, sir. Thank you for your encouraging words, sir.
साथियों, हमारे बीच आज CDIL के प्रेसिडेंट मिस्टर पंकज गुलाटी जी बैठे हुए हैं. मैं उनको मंच पर बुलाना चाहूँगा और उनसे अपने एक्सपीरियंस शेयर करने के लिए अनुरोध करता हूँ.
Mr. Pankaj Gulati ji has over 40 years of working experience in the semiconductor manufacturing industry. He has worked in all segments of semiconductor manufacturing, wafer fabrication, assembly and test. The podium to the side.
Thank you. Thank you. My compliments to SCL team and CDAC to organize this. It's really very nice to be present here in front of my gurus, Dr. Zorabi, Dr. D.N. Singh, with whom I've studied and gone through my college days. So 40 years I've been in this industry, semiconductors, but in the last 5 years I've seen how it's changed. I'm probably a misfit here because I'm not from a startup. We have been running semiconductor manufacturing for the past 60 odd years. I'm working for a company, CDIL, and I've been working for this company over 40 years after I passed out from my IIT. And I did come to SCL when Dr. Zorabi was there. Always a dream to work with SCL. Now, to summarize the whole thing, I would not take long, because I'm standing between you and the lunch. so I'll cut it short. My experience with SCL has been very pleasant. Honestly, what it was 10 years back, 15 years back when I used to go, because my friends from IIT, a couple of them joined SCL, so I was fortunate to go into SCL and see those Kodak chips, I think watch modules were being made at that time. And there was a huge production line running on the Shinkawa die bonders, wire bonders that I have seen, and the wafer fabs. But then something changed, a very unfortunate incident happened, and then it rebuilt itself. So coming back to it, we have our own manufacturing facility of, again, probably for many of you it will not be that glamour, although I have done my education in the ASICs and the CCDs, but we are working currently in the discrete semiconductors. So we are more into the micron and not into the nanometers type of a technology in the fab. But I think what I'll touch upon for a brief couple of minutes is that we have a plant in Mohali, which is adjacent to SCL. We share the same boundary wall. This has been there for the last over 20 years. And I've been trying to work with SCL for the last 15 odd years to try and develop. We had our own wafer fab. In fact, I'm a fab engineer. So we had our own wafer fab from 1972 till 2008. And then we shut down the fab because it was not economical to run the fab at that point of time. We were running, last shutdown was 4-inch fab in 2008. And then since then, we went more towards OSAT 80MP. So we've been procuring our wafers. We transferred our designs to foundries outside. Been procuring our wafers for the last over 15, 18 years from those foundries. My focus with SCL was to develop our wafers at SCL. In the last 7 or 8 years, things have changed. In fact, in the last 2 years, they have changed rapidly. The SCL team who was here, I have had the opportunity to meet each one of them. And all of you are interested to work with SCL, let me just re-emphasize that it's an excellent team to work with. We gave them a process. We had a couple of meetings almost every 2 weeks, 3 weeks, used to sit with them, work out the design, work out the processes. They had no idea about the discretes that we were manufacturing, but the team was so open and so clear on how they would like to proceed that I was very happy working. And then my engineers used to go there every 10 days, every 15 days. And I'm very glad to inform you that the first transistor wafer has been developed at SCL. Thanks to the SCL team, compliments to them. We already have a wafer available with us, which is now under evaluation at the final stage. When we started 6 months back, we signed an MOU with SCL 1 year back. When we started about 8 months back with them, with very little hope, very few people expected something to come out. But today I am confident, and my aim and target is, this is being done on an 8-inch fab. My aim and target is that we have 7 geometries currently being sourced from outside India foundries. In the next 2 years, we should bring all those geometries into India and get SCL fab into a commercial operation. SCL is doing a lot of development activity in the high end, but as a person who's worked in the commercial part of the semiconductors, I believe that there has to be a standard fixed DC level of commercial sale for SCL, and then on top of it, they should build it up. Unless you have a DC level commercial sale and you are profitable, at least cash positive, you really cannot move forward and keep developing. It should be a commercial organization, and today's session and the team enthusiasm that I've seen, I think we are moving in the right direction. So my compliments to the team, and I look forward more exciting times ahead working with SCL. Thank you, everybody. And I can promise you, SCL is really moving forward and changing itself. The face of SCL is changing. Thanks to the DG and thanks to the Ministry of Electronics and the team here, they are changing. Very enthusiastic people. You go there, they try to pull you and show you their capabilities. This is the type of team. I've traveled Taiwan, Korea, Japan. The team here is so excited to look forward to development of semiconductors, and compliments to all of you. Thank you very much. Thank you.
Thank you, sir. I would request Sri Manoj Wadhwaji to present a small memento to Sri Pankaj Gulhati ji as a token of gratitude.
Thank you so much, sir. Thank you so much. My pleasure. Thank you very much, sir. My pleasure. Thank you.
हम सेक्रेटरी साहब का इंतज़ार कर रहे हैं, 2 मिनट में वो आ रहे हैं, फिर अगला कार्यक्रम करेंगे।
अंशुमन सर का स्टार्टअप्स बाद में। Okay, sir. Yeah.
Okay.
We extend our very warm welcome to Shri Anshuman Tripathi ji. He is a member, National Security Advisor Board, India's National Security Council, a Sloan Fellow from Stanford's Graduate School of Business, and specializes in creating entrepreneurial ecosystem worldwide in semiconductors, cyber physical systems, aerospace, and defense.
Sir started his career in R&D division at ST Microelectronics, New Delhi. He holds a US patent in ASIC post-processing. So his research on semiconductor Trojan was also acknowledged by US Department of Defense. As a ASIC designer, his ASICs have accumulated sales of over $1 billion US. He has hands-on fabless design experiences from 180 nanometer to 32 nanometer nodes.
Sir, we welcome you for your keynote address of this event. Please join me in welcoming Shri Anshuman Tripathi ji.
Thank you, SCL. This is very characteristic of the opportunities that I usually get. The senior leadership just left right before Zarabi sir and all the people that I've respected, we've grown up, at least when CDIL Pankaj Saab was speaking, at least they were there. But thanks for this opportunity. Welcome to all the senior leadership from METI, SCL, industry, academia. We've got startup founders, potential billionaires, unicorn makers, everybody here. We've talked about a lot of opportunity SCL provides. Is there a clicker? We have talked about what all opportunities SCL and semiconductors can have in India. I'll take a road less taken, and I'll share some opportunities and give you some ideas that will be of interest as you go home from here. I'll talk about something called compatible chips. You've heard of IBM PC compatible. We've heard about different compatibilities. I'll talk about a hidden strategy, but before I go in there, a small promo for SCL is in order because this is an SCL event. Which is the best tech node for startups internationally, if I have to ask you? Any guesses? I mean, if 180 nanometers. 180 nanometers is the most lucrative, most important startup-based tech node. Now, many of you are already twisting faces. Is it 180 nanometers? 180 nanometers, 8-inch wafer. Now, this is not my slide. The blue slide is an official Intel slide from back in the day from my old good friend Paolo, who was one of the chief strategy for the platform for Intel. If you look at this slide, you will see that 180 nanometers is where Pentium 4 was built, where Itanium was built. You can do a 2 gigahertz design in 180 nanometers. So if those of you who say, you can't do a high speed in 180 nanometers, you can do 2 gigahertz. And I'm aware that at SCL they have PLLs which go to 1 point something gigahertz. They've already proven designs which are in the 1 to 2 gigahertz range. So if somebody tells me you can't do high speed in 180 or that the chip is very bulky, I'm quite sure you're not making a Pentium 4 size chip. Go in, do some research, you'll find what size is an Itanium. For those who want to take a photograph or something, please feel free. I want everybody to be well, adjusted to the fact that 180 nanometers is here to stay. Even at TSMC, about 30% of their revenues come from 180 and larger nodes. Why? Why is it good for startups? A startup is where business, demand, and market meet technology. If you're just talking about making a startup for a new technology which doesn't have a market today, then how will you survive? We have to seriously take a look at it. So, whenever you make a startup, the first thing you have in question is, where will you sell? Will the person buy? In the American parlance, there's a very interesting phrase which is used. Will the dogs eat the dog food? If I make a product which nobody uses, then it's not a startup. Your startup will not become a unicorn. It will just be baby corn. So you have to make, so it's the cheapest node which is available. The wafers are cheap. IPs are available. People have proven experience in IP. Mask making is cheap. There are multiple companies which make it. There's a lot of analog design which can go much easily into it. And if by any chance you're looking at making a space-grade chip, you are in for luck. As I've said, in multiple platforms all over the world, there are not that many fabs who can boast of having sent their chips to space, to places like Mars and the moon. Thanks to SCL, we have been able to send chips there. And now, thanks to METI and the Government of India's policies, we have the opportunity to provide that to you. You, as the founders of startups of Indian origin, every word has a meaning when you're working with the Government of India. So, you can actually make a space-grade chip which will be one of the world's best. We have proven technologies here. And then some naysayer will say, yes, sir, but you can only make an MPW. I can't make large volumes. What I'm told is that if you have a GDS2 which is taped out for SCL, there are other fabs in the world which will accept that exact same GDS2 and take it to high volume production. You want a full mass, dedicated mass set, you can actually do that too. So that ends my promo for SCL. I welcome you guys to use SCL as much as you can. And now let's get on to the hidden strategies. So if you see all these drones, I work in national security, we did a lot of analysis. You see all these drones of different shapes, forms, configurations. What do they have in common? Something more than flying and a little more than a chip. Yeah, you're going in the right direction. A little more. I'll tell you. They all use, no, not all of them have fans. Some of them have wings. They all use the same flight controller called PICSOC. And the PICSOC, the brain behind the PICSOC is a chip called STM32, made by my former employer and the former employer of many people sitting very proudly in the crowd. And STM32 powers almost all, no, I wouldn't say almost all, but a very high percentage of drones that fly globally today. Now, as I said, I promised that we have to look at business. We have to look at the market. Technology is great, but if I can't sell it, I'm not interested. If you look on the right, if you go on Amazon and look for PICSOC, if you go on PICSOC, you will see it sells for about 14,000, 15,000 rupees. But that only got 1 star. Why? Because there are people selling it, if you look lower down, there are people selling it for 7,000 rupees. Or if you can get to the right shop,
in Red Fort area, you can get for 5,000 rupees. Now, when you put up a chip for 5,000 rupees and compare 15,000 rupees and a product, the first thing people start saying, so that's Chinese, so it's price dumping, it's this and that. Price dumping is easier said than done. A lot of people will talk about, oh, sir, that's a Chinese product. Okay, maybe. But for the time being, let's focus on STM32, a very, very well-known microcontroller. STM32 has a full umbrella. There are low power, high speed, different peripherals come into the picture. They have maximum applications that you can think of. 12 product lines, or how many is it? 18 product lines and 1,200 actual product, different variants. Huge, huge market. If you actually look at the microcontroller market of the world, 82% of all microcontrollers sold in the world come from 5 specific companies. And in those 5, if you actually see, I've shown the IC Insights. If you're actually serious about doing a startup, you know what IC Insights is all about. And 2021, you might say, oh, the data is dated. I've been showing these slides from before. Believe me, I was up pretty late last night trying to make these slides. 2021 is the last time IC Insights published that data, and that's why that's the latest I could get. But if you see the top 4, NXP, Microchip, Renaissance, and ST, they're pretty much equally distributed amongst the market. Pretty close that they have. 18% to 16%, that's pretty close to each other. The top 4 are actually almost equally distributed. And if you are going to do a startup right now, when you go to a venture capitalist, you'll have to show projections. What is the market you want to access? That market is shown on the right side. If you actually look at the data, right now the total microcontroller market stands at about $32 billion US, but it's supposed to go up by 2 to 3 times by the time you hit your unicorn status. So that's a very good area to be in. And then you'll say, yes, it's a good area to be in, but ST Micro has already bought that. How are you, man? Welcome, Secretary Saab. I would like to say the Director Saab is very strategic about it. We have just reached the right place when you've come in. We're talking about SCL and the hidden strategies that can be utilized in Indian semiconductor market. So if you look at the total STM32, just one specific microcontroller, if you look at the smallest, that blue circle, that is how much revenue ST Microelectronics makes from that chip, which is called STM32, and that whole umbrella of chips. Their serviceable market, many of you who have done MBA would know, serviceable market is the orange part, orange circle. And the total accessible market is a big circle that is already there. But if I look at the whole picture out there, what is that green area there? What is that real market? That is a market area of STM32 which is not utilized by STM32, the French company. You would say, then what is this area utilized by? Who utilizes this? This area, lo and behold, is utilized by STM32 compatible chips. There are a lot of people in here. Say it again. Has anyone seen a STM32 compatible chip? I mean, you might say you can get one from NXP or something. No, that's not what I mean. When I say compatible, that is an example of a compatible. that those who use STM chips know that's a STM board called the Nucleo. And that chip on the left is an ST32 chip made by ST Micro, but on the right is from a company called Giga Device. Any of you heard of the company Giga Device? One guy in the whole group. Giga Device is the STM of China in many ways. If you look at this chip, this is pin-to-pin compatible. So I can take a STM board, I can take out an STM32 and I can put a Giga Device chip and it will work smoothly. When I say smoothly, what do I mean? There are two kinds of compatibles. One is called a drop-in compatible, one is a pin-to-pin compatible. A drop-in compatible is that even the source code that you've compiled into the ROM, it does not know the difference. Absolutely. 2011, for the first time, this was looked at by the US DoD because anti-submarine aircrafts of the United States Navy suddenly had failures which they didn't know where they were coming from. The chips looked fine, but they were not doing what they were supposed to do because somebody, thanks to the L1 model, had used cheap chips, and that's a tongue twister, cheap chips, to get it sourced from not the correct and appropriate places. So compatible chips, drop-in compatible. How many do you think are there drop-in compatibles of just STM32? Any guesses? One company I've already shown, Giga Device. Any guess? One? You did a survey. Good. So at least one guy is aware. 4. Any other number? So STM32, which many of you might think is a proprietary chip, has 4, according to the gentleman there, market compatibles being sold, and people are making money and paying their employees' salaries and being able to sustain a business. How big is the microcontroller unit market? That even after STM32 is selling from ST and making money, there are companies which are selling by the same brand name, not the same brand name, but the same market with the same pin-to-pin compatibility. What happened? Here are 4 companies which make STM32, the exact same chip, STM32F103 CBT6, exact down to the, everything, the size of the RAM, the clock speed, everything is in here, the same thing. 4 companies which are making it. As the gentleman out there said, and when I show you the last slide, you might think that I planted him there. I didn't. Let me tell you, I don't know the gentleman. 4 chips making STM32, and those are actual photographs of the chips that I could get from the internet. We stumble upon this because we actually got a spurious chip in one of our products that we were actually investigating, and that's where we started to look at this. Now, not just 4, there are 3 more companies out there whose chips are being sold STM32, and there are at least 3 other companies whose photographs I haven't put. There are at least 10 companies out there who are making STM32 chips. Same product, down to the same markings, down to the same pin level, everything is the same. This is pin-to-pin, drop-in compatible. You put the same ROM code, you take out this chip, STM32 chip, you put in this chip, it will work. And many of these companies you've not even heard of. These are all fabulous companies. I would say they are fabulous companies. They are actually eating into STM's market. Now some of you think, oh sir, this is illegal. This is not right. This can only happen in China. Well, let me tell you, there's one company at least which is made out of Taiwan, or at least its website is out of Taiwan. So that brings STM32F103 CBT6. You can go Google it. Why are these products selling in the market? They are selling As you can see from the pricing, they are one order of magnitude cheaper, at least one order of magnitude cheaper. I'm showing you the website, the distributor whose website this has been taken from. Those are the chips, and that's STM32. You buy one, which is $19. You buy the cheapest from MegaWin, which is Taiwanese, you get one for 1.7. They do the exact same thing. So all those people who are looking to get into business of making chips for the Indian ecosystem, please don't buy into the narrative that, oh, India doesn't have design ownership. That is why we have not been able to sustain the market. What design ownership? The design is right there. These are chips which are filling into the known designs of the international market and making up products which are one order of magnitude cheaper. So your bill of materials pricing comes down substantially, because in any BOM, about 50 to 75% of the pricing is just the chips, of which about 90% is that only of the main processor, the microcontroller or the microprocessor. And if you can get that down by an order of magnitude, you've hit a jackpot. You are going to become a unicorn. So now let's come to the next one. What is a pin-to-pin compatible, which is not a drop-in compatible? So my Chinese friends have gone one step ahead. They've taken an STM32 and they've replaced the ARM processor with a RISC-V processor. And we're giving you the exact same thing, which is pin-to-pin compatible, and coming to a product which there is no way you can go and sue them in court for. Sir, this one uses RISC-V, so that one uses ARM, sir. We are completely different, sir. So you've got a product which is far superior. You only need to write the software code. Is this legit? If these 10 companies did not steal the GDS2 from ST Microelectronics, they are pretty much going to be legitimate. If the IPs were procured in a legitimate fashion, the IP rights were maintained and respected, for the USB core, the I2C, whatever, either they made it or they got it from some other company, if they were all kept in. But as you go on the internet and you actually look at the market for these chips and you see how much people have used it, they're not exactly 100% the same. There's slight variations. Maybe that's because of poor quality and sometimes by design. But there are slight differences, so they're not 100%, but still 99.8% I would say they are the same. So going on to various websites, you will find people providing different products and telling you why this PICSOC is 15,000 rupees and why that one is 5,000 rupees and why the chip is different and how to differentiate one chip from the other. There's a lot of sizable data and lot of analysis people have done. So compatible chips is another area in which our friendly neighbors have built an ecosystem. If you are a startup looking to get into the market with a cash flow, this might be a strategy you might want to look at. You have a product which can straight away integrate into an international product line with a Make in India flavor. Thank you so much for this. I guess I'm going to be here. If you have any questions, feel free to reach out to me. Thank you.
We would like to invite Secretary Sir to give the memento to Anshuman Tripathi Sir. साथियों, इस SCL मीट को अपनी गरिमामयी उपस्थिति से सुशोभित करने के लिए हम इलेक्ट्रॉनिकी और सूचना प्रौद्योगिकी मंत्रालय के सचिव माननीय श्री S. कृष्णन जी के प्रति हार्दिक आभार व्यक्त करते हैं। सर, हम आपका हार्दिक स्वागत करते हैं। महानिदेशक SCL से अनुरोध है कि पौधा भेंट कर सेक्रेटरी सर का सम्मान करें।
Moving to the next segment. Moving to the next segment of today's program is the release and handover of SCL designed and developed multi-core reconfigurable data acquisition system to a ISRO representative. We would like to request our honorable chief guest of the event, Secretary Sir, to kindly hand over the plastic package version of the device to Madam Padma Priya from URSC Bangalore.
This device is equipped with 16 number of simultaneously sampling sigma delta ADCs with 24-bit resolution. Designed and developed for avionics miniaturization, device is completely realized at SCL. It is inducted in launch vehicle onboard telemetry packages and has also been proposed for integrated vehicle health monitoring system for Gaganyaan project. Now I would request Krishnan sir to release and handover of SCL design and developed 16-bit cyclic ADC to ISRO representative from SAC Ahmedabad, Sri Gurvinder Singh Ji, Scientist G, Space Application Center, Ahmedabad.
This device is a Nyquist rate ADC based on cyclic architecture. This device is end-to-end realized at SCL. Design has been optimized for power efficiency and high frequency. Next is the release of new application, ARTS, developed by government DLI scheme funded company AHISA. I would like to request Secretary Sir to kindly inaugurate ARTS developed by AHISA.
AHISA RISC-V test suite ARTS offers a fully automated environment to validate RISC-V processor core, self-validating environment, generate randomized vectors to achieve exhaustive functional coverage.
Also, I would like to announce 2 DLI applicants supported by CDAC, MindGroup and INCO.
We request representative from MindGroup and INCO to come to the podium, and we request Secretary Sir to facilitate them with the memento.
MindGroup Technologies Private Limited is a startup incubated by IIT Madras and co-incubated by IIT Madras Pravartak Technologies Foundation.
INCO Semiconductor Private Limited is an innovative startup based in Chennai.
Thank you, sir. Startup experience is not enough.
Thank you, sir. It is a great honor to invite our esteemed chief guest for today's meet, Sri S. Krishnanji, a highly accomplished individual in Indian administrative services, who has made remarkable contributions that resonate deeply with the theme of today's event.
With a career spanning over 35 years, he has held significant roles, including a range of assignments in the government of Tamil Nadu, Government of India, and International Monetary Fund. Secretary Sir had been a driving force behind many projects and has consistently demonstrated a commitment to excellence, innovation, and community services.
आपने इंटरनेशनल फाइनेंशियल आर्किटेक्चर और ग्लोबल फाइनेंशियल सेफ्टी नेट्स पर G20 विशेषज्ञ के समूह में भारत सरकार का प्रतिनिधित्व किया है और वर्तमान में आप भारत सरकार के इलेक्ट्रॉनिकी और सूचना प्रौद्योगिकी मंत्रालय में सचिव के पद पर आसीन हैं। सर, आपको स्टेज पे बुलाते हैं, हम आमंत्रित करते हैं और हमें मार्गदर्शन दीजिए।
in welcoming Secretary Sir.
I'm acutely conscious that we are very, very close to lunchtime and I shouldn't hold you from your lunch for much longer. Director General of SCL, Shri Kamaljeet Singh, Shri Anshuman Tripathi, Executive Director of CDAC Mohali and CDAC Noida, colleagues from MEITI and CDAC, SCL and other institutions, academics including, I can see Professor Udayan Ganguly from IIT Bombay, large number of startups and other dignitaries present here today. I think today is an extremely significant event. I don't know how many of you have actually attempted to go to SCL in Mohali. It's not very easy to get into that complex, right? There's a lot of security, there are many barriers you have to cross, and it's been one of those premises which have been securely guarded as an important national center where very important activity and research takes place. It undoubtedly is. But what we see now is significantly greater openness to actually participate in a range of activities which earlier were closed off to the private sector, closed off to entrepreneurs, closed off to people who wanted to collaborate. Whether it is the space sector, whether it is the defense sector or the semiconductor sector, all of these were regarded as closely guarded, national level, secret locations. But let me assure you, getting into any place where there is any semiconductor related activity is not easy. I've visited fabs all over the world, whether it is in the United States, whether it is in China, whether it is in Taiwan, in Japan, in a number of places. The protocols of actually entering, getting into the space, whether it is privately controlled, commercially controlled, or officially controlled, is always going to be difficult. There are barriers to entry. The costs are also significant, which is one reason why India has not made significant strides in this space for many, many years. We've had researchers, we have had others work in this space, but we have not really got into the manufacture on the scale that we expected. It's been many years since these efforts commenced, and the place where it all started is SCL in Mohali, and clearly that is a place where it all needs to go back to in some way for further developments to take place. So in that sense, that for SCL to throw it open, to invite startups, invite others to use their facilities, to actually give effect to the kind of research that they're doing is an extremely significant event. The government has announced a policy saying that SCL is to be modernized, SCL is to be made a center for research and development. SCL's facilities, in addition to being used for the strategic sectors like space, atomic energy and defense, will also be available for academics and researchers and others so that eventually we hope that we will not have to go out of the country or at any other location to actually get the tape out of whatever chips are designed in the country to be done, and we would be able to do it domestically. And that is an objective that we are determined to achieve. And an important step in that objective is to have enough people associated with the institution to actually use the kind of facility that it offers. The big challenge for India in this space is, while we have a fairly large design workforce, while we have a number of people who are working on design of semiconductor chips, the actual manufacture of it hasn't really happened in any scale, and our ability to actually do that kind of high precision manufacturing is still limited, and which is where pioneering institutions like SCL, which have whatever is the facility which is available in the country, that nature of facility is available there, and that needs to be utilized to the best extent possible to really spawn and really give birth to many more enterprises and many more institutions which can do this work and take it forward. So whether it is for Micron, who are establishing the first large-scale ATMP plant in the country, or whether it is for Tata Electronics, who will be setting up the first semiconductor fab of a commercial scale in the country, the mother organization, or literally the place that they need to go back to, will be SCL. And in that sense, the ability to throw it open to startups and the willingness to throw it open to startups is a very significant forward step, and I congratulate the DG SCL and all the senior staff members who are present here today that they have actually pivoted, they have opened themselves up, and they are willing to face these newer challenges in the manner that they are attempting to. I think that's a very, very significant forward step which needs to be commended. Equally, I think what is important is that we have to make sure that in a country which is starting a little late in this race, you had some interesting examples of how various kinds of leapfrogging can happen by hook or by crook, which Mr. Anshuman Tripathi presented to you a short time ago. I'm not advocating that we do those kind of things, but all that I would say is that we have to use every opportunity that we have and every resource that we have to get ahead in this particular and very difficult and very competitive space. We certainly have the ingenuity, we certainly have the talent, we certainly have the people who can make it happen. It is the government's job to make sure that this segment is adequately resourced and the policies are framed in such a way that you're all able to take advantage of it. The design-linked incentive scheme of the government, I'm glad that there have been 2 recipients today of approvals in the design-linked incentive scheme. This is extremely important. We've had about 20 odd approvals so far, and we need to really push forward significantly to make sure that more companies are able to take advantage of this, and these funds are utilized more effectively. So there are a number of startups present here today. I'm sure they would have explained to you about the features of the DLI scheme. If not, the officials of METI are here to give you more details about the scheme and why it is an important scheme in which all of you need to participate. Please do take advantage of this particular scheme. We also intend to open it up to a wider cross-section of Indian companies so that this is something which can be taken full benefit of. Adequate funds are available, and my request to CDAC and to my colleagues in METI has been that the processing of applications also needs to take place much faster. I think we don't have to be, I'm not saying that we have to be rash or reckless, but I think speed is essential. You have to preserve the enthusiasm of startups. They want to do things quickly. We can't tie them up in bureaucratic knots. I mean, leave the bureaucracy to me. You guys look at it on scientific and you look at it on the basis of whether this will work or not and whether it is a sound idea or not. We should be prepared to take some risks. Don't expect every startup to succeed. They will not. We are not here. I think everyone realizes that not everyone will succeed, but they need support in time and at the right time in order to actually make good. We should not be parties to killing a startup. Market kills it, some other circumstances kill it, that is a different issue. When we have startup support programs, those who administer the program should actually be people who support it, people who enable it, people who enable the startup to actually succeed, and not those who are responsible for not sort of supporting them in time and thereby ensuring their failure. So I think that is something that we need to keep in mind and make sure that these applications are processed quickly and assistance is offered in time so that they are able to make good and move forward. And likewise, we need to facilitate over time venture capitalists and others who want to participate a little later in this process to also come forward. And if we provide the early stage funding, then they can come in with subsequent stages of the funding. The DLI scheme also needs to be operated in such a way that this is enabled, because the funding that we may provide may not be adequate to cover the entire set of costs. Having a co-investor or a fellow investor is always a good way to increase what resources come into it, and at the same time give the startups an opportunity to interact with more mentors and more people from the market who can support the way forward. So I think all these new ways of operating and thinking, I can only say one thing to you: if SCL can throw open its doors and invite startups, you people should be much more proactive in encouraging them to take the next step. And I think that is the message that we really need to take away. We need to partner, we need to move forward, we need to actually make this into a very significant forward movement. And it is again strategically very important. Please realize that we will have a fab in 2.5, 3 years' time. We will have a fab in the country. Will you have enough IPs and technologies to actually load on to the fab so that it is able to function to full capacity? So there could be more than one fab, and then do we have enough in terms of technology being developed in the country for that to happen? We are all very fond of saying that India should become a product nation, we should be a design nation, and we should have IP of our own. Now, if we want all of that to happen, we have to actually support that process. We have to be proactive and help that to go along. So I really congratulate all the startups also who are present here, who are taking advantage of whatever the new opportunities are coming up, who are taking these risks and who are entrepreneurial in the way that they're willing to take a risk. Many of us who are on the other side, on the government side, we receive our salaries every month. We are all well protected. The ability to take a risk is a major risk. You and I don't do it. So respect the fact that startups are prepared to take that risk. And in the case of the startups also, I think you need to look at it as a sense of adventure, look at it as a sense of what can work, what can succeed. Do not be hesitant to seek support and help when you need it. But do not waste all your time on doing that, because you need to work on your research and actually innovating and developing your product. Government has a range of programs to support you. Just be seen and be accessible to the right opportunities and grasp and grab those opportunities whenever they come up for you, so that we can help you and we can sort of take this forward. And this is a very interesting mechanism by which an institution like SCL truly works its way towards becoming an R&D cum innovation institution and taking forward the semiconductor mission in this country into the next stage and into the next step. The belief that India can do it in the semiconductor space is actually now there. Some of it came when the ISM was launched. Some of it came when the first of the projects of Micron was launched. Some of it came when projects were awarded to the Tatas and the others. But it really came during the Semicon, the large conference which took place a month or so ago, when suddenly you found that the biggest companies of the world are actually in India, looking at India and looking to see how it can succeed and how it can work. You could almost sense there that each company was looking at the other, saying that if you're not here at this time, we may miss out on the India story. So you're all part of that India story, you're all part of what needs to happen. So make sure that this actually happens, and this is a very good first step. And when they say well begun is half done, I'm sure that this initiative by SCL will go a long way in taking the ISM forward. Thank you very much.
आज हमारे साथ जुड़ने, अपने बहुमूल्य विचारों को हमारे साथ साझा करने और एक नई दिशा दिखाने के लिए हम माननीय मुख्य अतिथि श्री एस कृष्णन जी के अत्यंत आभारी हैं। सर, हम आपके प्रति अपनी कृतज्ञता व्यक्त करते हैं।
We would request Executive Director CDEC Noida to kindly honor and felicitate our chief guest.
अब हम SCL महानिदेशक से अनुरोध करते हैं कि कृपया हमारे मुख्य अतिथि जी को एक स्मृति चिन्ह देकर सम्मानित करें।
Big round of applause, please.
Proceed करें। Exhibit.
So, we are excited to announce that we have exhibit on SCL capabilities and offerings. So you can kindly proceed there.
Thank you so much.
And ladies and gentlemen, now we will break for lunch break, the much awaited lunch break. The break will last for 45 minutes and you are requested to come back for an exciting panel discussions.
hello.
Hello, hello.
Hello, hello.
Please be seated.
Please be seated.
Next session is startup experience.
My feedback. Kindly take your seats. We want to start the next session. And we would also love to have your feedback. For the same, we have feedback forms available at our registration desk and a visitor book where you can write, comment your experience regarding this event.
Startup experiences. But it's okay.
So let's start our post-lunch session. That's about startup experiences. In India, I humbly request again, please take your seats so that we can comfortably start the next session.
In India, our journey begins with a clear mission to bridge the gap between the global needs for advanced semiconductor technologies and India's growing potential to become a hub for innovation and manufacturing in semiconductor sector.
We are committed to develop cutting-edge, efficient, and cost-effective semiconductor solutions that address both domestic and global needs. We aim to set new standards in semiconductor design, accelerate local manufacturing, and create a robust ecosystem that supports the growth of next-generation tech startups. Thank you, all startups, for being a part of this journey as we embark on this exciting venture to shape the future semiconductors in India and beyond. You will be glad to know that we have more than 30 startups participating today.
और अब हम कुछ भारतीय स्टार्टअप्स को अपने अनुभव हमारे साथ साझा करने के लिए आमंत्रित करना चाहेंगे। हम सबसे पहले मल्टी नैनो सेंस टेक्नोलॉजी MNST के प्रतिनिधि श्री शशांक कुमार जी को मंच पर आमंत्रित करते हैं और उनसे अनुरोध है कि वे अपने अनुभव इस सभा के साथ साझा करें। स्वागत करते हैं श्री शशांक कुमार जी का।
Hello. So good afternoon, everyone. I thought I would have a easy task because I had the third speech on the list, and now I'm doing the first in the post-lunch session. So I'll try to make it slightly exciting. I'm Shashank Kumar. I'm the CEO of Multi-Nanosense Technologies, and it's an incredible honor to stand here today celebrating a partnership that has been truly instrumental in shaping the future of our company. Our collaboration with SCL, which began in middle of 2022, is a shining example of what can be accomplished when innovation meets a shared purpose, intent, and unwavering support. I double underline that, and I'll tell you the story. So in early 2022, the world was just starting to recover from COVID, and we were going out into the industry trying to find a fab partner. And we received about 250,000 euro quote from Silex. We received a 1.2 million euro quote from IMEC. Both of them were willing to take our projects, but then the amounts were far beyond our capability at that point in time. Raising venture capital at that time would have placed the company at a great risk because the VCs at that point viewed our work as if it was too risky, to a territory too uncharted, and they would not they would ask for 50% of the company. Then there's no point working for it, right? So ultimately we felt like the path ahead was closing in on us, even though at that time we were working with IIT Bombay, but then we knew we can never achieve scale there. It has to be some place where we can manufacture millions of sensors. So that is the time when actually SCL opened up and SCL stepped in. And they provided fabrication services not only at the fraction of a cost, but also in record time. Now, their support actually allowed us to keep moving forward, even during the most challenging periods of our cash flow roller coaster. So had I not gotten into a financial distress situation within the company, which we've now recovered from, we would have probably had these chips with us a year earlier. But then, even though we've lost time, these chips are really doing well, and we've tested them out. We just received them 3 weeks ago. And we are really excited now that we can actually go into scale. We already fabricated 2,500 devices, which can get packaged and we can start selling them. Now, one thing I'm very particularly proud to share today, after hearing to all of the dignitaries, there's one common message that is coming in. And that is, like, India is now prepared to take the risk and support the startups and actually move at the pace that we want to move. So in that context, this MEMS sensor technology that we are working on was invented by Professor Vasant Kumar. He is an IIT Bombay alumnus, and he's been the head of materials chemistry at University of Cambridge for almost 40 years now. So we've basically turned it around a circle. We've licensed it exclusively for a global market from University of Cambridge and brought the technology back. We fabricated the first protos at IIT Bombay, which is his alma mater, and which was supported by METI under the INUP program. And now we are brought it to SCL, where we can actually volume scale it. Now, SCL didn't just help us with fabrication, they were also with us at every step, from chip on board packaging for our prototypes to even working with global packaging leaders like Kyocera. And we've had conversations where I'm now going to bring in NXP Semiconductors, who's also working really close with us, Kyocera, and then SCL team sitting in our corner to discuss how do we actually scale it and put all the things together and come up with a sensor. Today I learned SCL can also help me put a lot of electronics on the chip, which I don't have the capability today, or I'll have to build my own team. Else I would rather give it directly to SCL to start working on it right away. We are aiming for an automobile grade qualification for our products, where NXP is going to help us. But I today learned we can even go to mil grade and space grade levels right away. And there is so many verification tools, so many verification equipment that we can actually get into verifying whatever chips we have, and then if any design modifications are needed, we can really target and go to space grade straight away. Like even ISRO is one of our customers, they want some of these sensors, but then we were holding our hands back. But after listening today, I think we can even attempt that. So this journey is a story of Indian innovation. Like these gas sensors designed and developed and built in India, and they are really performing very well. There are several customers waiting for it, so it's not like we are going to go out and find a customer or a market for it. The actual people are waiting at Tata Motors, Cummins, Shell and Reliance, and including global leaders like Baker Hughes in Italy, some of these sensors that we will get handed over today will actually go to them. Now, looking ahead, we're also very excited about launching new R&D projects with IIT Bombay, which is supported by METI under the upcoming projects that are there. And here we'll be adding more sensing principles onto the MEMS device, and we hope SCL is able to actually help us scale that as well. So we would have a dialogue and see if possible the stuff that we want done on those technologies, if they can be procured under the enlargement facility creation direction. And none of this would have been possible without the Government of India's unwavering support, which actually has given us very high risk capital when others were hesitant. We've also been backed by a soft loan from the Technology Development Board, which operates under DST for our hydrogen sensors. And all in all, ultimately, I think this is a symbol of India's rise in the global semiconductor arena. Like 2 years ago, we could not imagine how we will volume produce in India. And today we are standing here with almost all the relevant people who will help me do that in the next coming year. So that's a short summary. So we are building an innovation that is born from Indian talent, supported by Indian institutions, and it is designed to serve a global audience. So I want to extend my heartfelt gratitude to SCL and all the partners who have believed in us. So here's to even greater collaborations and milestones ahead as we embark on this journey together. Thank you.
धन्यवाद शशांक जी। अब मैं डायरेक्टर जनरल SCL से अनुरोध करता हूं कि वे मंच पर आएं और SCL और MNST द्वारा जॉइंटली डेवलप 10 गैस सेंसर प्रोटोटाइप्स को श्री शशांक कुमार जी को प्रदान करें।
We also have representative from Chipex Private Technology, Chipex Technology Private Limited, Mr. Rohit Reddy. Sir, we request you to kindly come to the podium and share your experience in brief.
Hello all, I'm Rohit, founder and CTO at Chipex Technologies. How do I control the slides? So I wanted to briefly explain what our company does first. So we are a full stack company where we cover all the aspects of the chip design, starting from analog circuit, digital, RTL to synthesis layout. And not only that, we have tie-up with our partners wherein we take in for fabrication with SCL, and also we do packaging and also develop test board and silicon testing as well. So having this full stack capability along with our expertise over multiple tape outs in multiple domains ranging from 180 nanometer to 3 nanometer, we are equipped to handle complex tasks, which is useful in terms of making it in a fully Make in India product. In achieving this self-reliant Make in India product, we have already started our journey with SCL, which was the 13th item in the list of IPs shared by SCL, which was the 1.2 gigahertz PLL. So there the ownership was full, right from specification to silicon. The specifications were discussed with Deep sir and his team, and testing was done by Sumit and his team. So yeah, it was a first pass silicon success, and we demonstrated that we are achieving speeds of 1.2 gigahertz with a reasonable DJ and RJ numbers for the PLL. Next, these are some of the results from the PLL which we have developed. So there is the test board which was done, and these are the I diagrams and the jitter numbers for the PLL and the block diagram. So these are the steps which we already have traveled with SCL, and we continue to take it further by proposing another list of IPs which we already started discussions with SCL. So regarding the IPs which are the devices which are coming up, like the 40 volt DMOS devices, with those kind of things we can achieve more power management type circuits or the LED drivers, which we are keen to develop and work with SCL. I would like to thank Deep Anil and Sumit for extending the hand in making this silicon a success. Yeah, and also on the other level, where you have small interfaces for the SoC requirements, usually have the SPI I2C and the UART type of, and the AHB type interfaces. Those we are also developing along with SCL. And which in turn, like there was an initial discussion in the beginning that we want to have it like a two-pronged approach, where we want to propose in a product too in the upcoming DLI scheme, and also be capable of providing IPs which can be used by multiple companies who are doing their own products. So that's our approach. Yeah, this is just why you have to choose us. And even the MEMS technology which you are talking about, we could use it. I mean, if you don't have the electronics for it, we can build a capacitor to voltage sort of converters and make it to whatever is needed in the digitized form. Yeah, even the FPGA developments in the morning, somebody was asking the FPGA thing, whether we can siliconize it. We can make the ASIC for it once you have the concept proven in FPGA. Yeah, that's pretty much about us. Thank you.
Now, let's move to today's most awaited technical session, which promises to be an exciting exploration for today's topic, tapping of SCL 180 nanometer technology for Atmanirbhar Bharat.
We have an excellent lineup of experts and visionaries who will share cutting-edge insights, innovative research, and practical applications in semiconductor technology. Today's session will cover SCL 180 nanometer technology, and we will discuss how it can be used towards our Prime Minister Shri Narendra Modi ji's dream of Atmanirbhar Bharat.
अब हम स्टेज को अपने मॉडरेटर मिस्टर दीप सहगल को समर्पित करते हैं और उनसे अनुरोध करते हैं कि वो आएं और इस सेशन को स्टार्ट करें.
I would also call Rahul Khandelwal ji, who is a senior ATMP engineer in our office. He will also be co-moderating the session with me. So, very good evening to all of you, and we are entering into a very, very important event, part of the event where we will be listening from the veterans, we will be listening from the dignitaries, experienced people of this field. So, maybe Rahul, over to you. Yeah.
So, hello everyone, I am Rahul. So, to begin with the event, we would like to invite our panelists. So, first I would like to invite Mr. Pankaj Gulati, President, CDIS Semiconductors Private Limited. He has over 40 years of work experience in the semiconductor manufacturing industry. He has worked in all segments of semiconductor manufacturing, wafer fabrication, assembly and test. He has executive working experience of running a semiconductor manufacturing unit, manufacturing and sales. Thank you, sir.
Our next panelist is Dr. D.N. Singh, who is a CEO at present, Burjan Solar Power Energy Limited, and he is also ex-executive director, SCL. We very much welcome you, sir. Invite you on the stage. Please have your seat. Dr. D.N. Singh has been the executive director and spent 24 years in the professional career at SCL, and he has established and ran first commercial 4-inch, 6-inch VLSI and MEMS fabrication plants there.
Yeah, next I would like to invite Professor Udyan Ganguly from IIT Bombay. His research interests are in semiconductor device physics and processing technologies for advanced memory, computing and pneumomorphic systems. He currently serves as the first professor in charge for IITB Center for Semiconductor Technologies. Welcome, sir.
Our next panelist is Dr. Rohit Sharma. He is a faculty in the Electrical Engineering Department of IIT Ropar, and since 2012, and he spearheads the research activity in electronics packaging. So he is a packaging person, and audience may please note it, and we welcome you, sir, on the dais. Yeah.
Next, I would like to invite Mr. Rohit Reddy from Chipex Tech. He is CTO of the company, an alumnus of IIT Kharagpur. He is the co-founder and CTO of the company. Before starting, he has worked as analog design engineer in SanDisk and principal design engineer in Cadence Design Systems. Welcome, Rohit.
Now we invite our next panelist, Shri Sagar Sharma ji from Indian Semiconductor Mission. We welcome you, Sagar ji. Please be seated. Please invite you on the dais. He is an enthusiastic public policy professional currently working as the Chief Staff in Ministry of Electronics Information Technology, Government of India. Having graduated from the Indian Institute of Technology, Bombay, he is also maintaining STEM education across India and co-founder of the NGO Vigyan Shala.
Now I would like to invite Ms. Padma Priya from ISRO. She is a scientist with 20 years of experience in the design and development of ASICs, SoCs for spacecraft avionics in ISRO. She is presently heading the analog and mixed signal design development team at the URSC. She has got a patent for configurable SRAM design for space applications. Welcome, ma'am.
With the very eminent, distinguished panelists with us, it is our pleasure to have them here and to open up the important discussion with the topic tapping of SCL 180 nanometer technology for Atmanirbhar Bharat. And with this topic, I am just setting one ground rule that we will be taking the questions from the audience in the last 10 to 15 minutes. We will be pre-announcing it. So please hold down and please write your questions. Session will be around 45 minutes to 60 minutes. Now we are straight going to our first important question, which is open to all panelists. Sirs, madam, we can have maybe your concise view of how do you see this particular point. There is a lot of spotlight which is nowadays going in the 7 nanometer, 6 nanometer, 5 nanometer, down to the regimes of even angstrom. But what we are talking here is, where is the role and the power of the legacy node like 180 nanometer and above? So we would like to have the perspective, how do you see what role these legacy nodes of 180 nanometer can play and SCL 180 nanometer in general can play for the upbringing of this dream of Atmanirbhar Bharat. So we start with Dr. D.N. Singh, and yeah, sir, we would like to have your views.
Okay, good afternoon to everybody. And to start with, I will thank a lot to SCL management, especially Dr. Kaljit Singh and Manoj and Sagal, for inviting me, because I am sitting on some SCL related function after 18 years. I left SCL in 2006. So you can imagine it is very emotional and kind of nostalgic moment for me. And I'm so happy to see that what we started 42 years back. I'm saying we started that because I am the first set of people who were involved from the first brick onward to build SCL. And I can see that after that 42 years, hence SCL is playing a great role. When India has decided that no more, we can live without chip technology, chip fabrication in the country. Though realization has come after a long time, I wish it could have come earlier, but still, at that time also, if SCL has survived so far, I am 100% sure that it is going to play a key role. As far as technology is concerned, it was difficult at that time, 1982, to bring technological partner or start chip making in India. Some people never imagined that it can happen in India, but it did happen. Similarly, it is difficult today, and a lot of water has flown under the Ganges. After that, coming to the nodes, you will be surprised that we started with 5 micron technology, 5000 nanometer. Today we are talking about 3 nanometer. Straightway, some 5,000 times lower than that nodes. But one important thing I have observed, though I have been out of semiconductor field as such for 18 years, now I deal with solar technologies, photovoltaic technologies, which is also a kind of product of semiconductor material, but their technologies are different. The way of doing things are different. So when we started in 1982, there's one thing goes on in this microelectronics, is that this is not the node where all the products which are required to drive the electronics world are made in the same node. There's never. When we were doing 5 micron, then 3 micron was getting into large production, 2 micron was in labs. We were only one generation behind. We did 3 micron in a pretty fast time. Then we did 2 micron development, 1.2 micron. So up to 0.8 micron, 3 to 0.8 micron technology were running together. And as the technologies have moved in the nanometer scale down and down to 100 nanometer and below, to 80 nanometer, 65 nanometer and all that, and coming to 3 nanometer, I can observe and I can see that the product range has been larger and larger, which has not scaled to the lowest nodes. So there are nodes which are I think 1,000 times more or maybe 500 times more than 3 nanometer. 3 nanometer is required by very select and very high speed kind of devices, all you know better than me. But 180 nanometer node today also is attracting a lot of products, and a lot of products are there which cannot be done in any other technologies in a better manner than a 180 nanometer node or maybe 90 nanometer node. I can share only one product from the field where I come from, in solar. All of you know the solar energy and the semiconductor. Both are getting emphasized by the present regime of government. And we want to produce 40% of our electricity in the country by 2030 by solar energy, solar electricity. And there again, around silicon is the basic material, and the front-end technology is like semiconductor. Around 30,000 megawatt of production of solar cell and solar power plants is going to happen in India. The one electronic item without which solar revolution cannot happen in the country is the inverter. To convert the solar cells convert DC into AC, and then only it can be transferred to the grids and then distributed. So the inverters are the one electronic device where the IGBT is the device. And IGBT today is a high voltage device, and Umapati, my colleague, is here. He has worked on the high voltage devices. SCL has a long experience in high voltage devices, and that product can very well be done in that kind of technology. And there are many other related products in that, what we call MPPT, maximum power tracking, which require DC to DC converters and things like that. And then power management ICs and all that. All these ICs, for them, node is irrelevant. 180 nanometer is good enough. Of course, I will not say that it is more than 100 nanometer. 315, 215. Even there are some IGBTs from some companies which are built in, being produced in 250 nanometer. So we have not to be disheartened that we have only 180 nanometer at SCL, and what products we can do. We have enough products, only the matter of, I cannot answer all of them, but there are enough products which can make SCL viable. The only important thing is that we have to do it in volume. And couple of things have to be seen there. Unfortunately, the culture of commercial production has to be brought in, and then still being a government organization, pardon me if I become frank about certain things, people have to be incentivized, have to be enthusiastic about doing things in commercial scale, and that culture has to be brought in there. Other important thing is that marketing. If we do products, but our past experience also in SCL, that our reach in the market, how we can take the products to the market and compete with the similar products, which are from the very well-known organizations. I saw that announcement, the party talking about drop-in kind of things, devices. Okay, you can do that, but still it's marketing in those competitive environment in Taiwan or somewhere is a very, very difficult thing. So that has to be given emphasis. How do we take to the market any product which we build? First we have to build to the same quality, same level, at the same cost, and then we have to take to the market. And it is not very difficult. Being in India, we know, I don't know how many of you heard here, the startups. There's a company called Mass-Chip in Hyderabad. They have built product in India and then sold globally. Of course, they have got it fabricated. I was very happy. Manoj told me that they are doing some product for them. So those people know how to get into the market. So we have to collaborate in such organizations, the fabless, basically the fabless product manufacturers, who know that which product can get into the market if manufactured here with the same specification, with the same quality. That's number 2 point I would like to make. Other thing is, which I can see that one gap here, and Manoj and all that, they will know why I'm saying what I'm saying, that mask making is a missing link in the whole value chain, in the whole. SCL has everything, from wafer fab, packaging, testing, quality assurance, all you saw that since morning, that they have almost every capability. When we started, we had mask make there. So it was completely integrated. So somewhere SCL is in a position that they can work with the DIT and then bring in a mass fabrication facility in the country, and that can help this all startups and the multi-product wafer going on, things like that.
Surely,
so
sir.
that's the one suggestion I would like to. Rather than taking more time, will again thank you very much, Dr. Koljit Singh, for organizing such a beautiful function and startup meet. And only thing at the end I would like to say that it is not a startup. It was in 42 years back. So it should be scale-up meet. So I would like to rename it a scale-up meet rather than a startup meet. And then I am again becoming very emotional. This our logo. Logo is very, very dear to me because it's the first to build it and send it to the mask making shop to incorporate in the machine so that this logo is printed everywhere. And whenever I see this logo, I become very emotional. So thank you very much for listening me. If any question, I can answer.
Thank you, sir. And we are moving to Dr. Gulati. With sir, we are expecting from you one angle to be added, being in the discrete devices, Continental CDIL. How do you see the discrete devices things related to 180 nanometer?
Thank you very much. Thanks. Privilege. Very happy to be part of this panel with one of my gurus, Dr. D.N. Singh at IIT Delhi. I've learned from him quite a bit there. Sagarji, who's now really working hard in supporting the industry, semiconductor industry. Professor Ganguly, who I've been in touch with for a couple of years. Okay, coming back to this issue that you just raised. Yes. Me and Sagarji were just discussing 10 minutes back only. I think 180 nano, what in the morning Mr. Anshuman Tripathi also said, it's a very sweet node. Almost all these startups are at this node. But my background being now being in discretes, I think everything that we make in discretes can be covered with 180. In fact, we were working when we had the wafer fab. I was doing about 1.2 micron that time in 1990s, late 80s, 90s. And we had a wafer fab. And some of you may be surprised, but we were doing about 8,000 wafers a month at that time of 4-inch. And we were exporting 6,000 wafers per month to China. That's the type of volume we were doing at that point of time in 1998, 99. And it's now changing. We were exporting transistors, Zener diode, wafers to China. We were using only about 2,500, 3,000, and every month we used to export huge quantities. Then the volume started dropping because we were changing from 4-inch. We planned to change to 6-inch. We did not. So we stopped because it was not economical to run the fab at that time. Many reasons, because go to 6-inch, then your volume in any fab. Now, the reason I'm touching this is in any fab, if you have to be a profitable fab, you must be doing about 8, 10, 15,000 wafers a month. A small volume will not really make fab profitable. But to answer your question, 180 covers everything. And when I talk of everything, transistors, Zener diodes, MOSFETs, IGBTs, everything is covered. And in India today, many OSATs, ATMPs are coming in this segment of discrete semiconductors. So it's time that what Dr. Singh said, market. We must go and meet some of these ATMPs which are coming up and tell them that we have this capability of doing the fab in India. Please look at it. Okay, you will be an OSAT facility for somebody outside who will give you a wafer and you will assemble. But if you want to build your brand, if you want to build your volume, and India has a huge demand of MOSFETs. Every EV uses 16 to 25 MOSFETs in the electric motor everywhere. So it's a huge demand of MOSFETs, and today 100%, okay, CDL is doing some of it, but 100% almost is being imported from China. So it's an open secret. MOSFETs, IGBTs, transistors, everything is possible in that 180 nano, sir.
Yes, thank you. Thank you, sir. We are moving over to Professor Ganguly ji. And if you can be in brief, tell us this power of 180, how do you see this thing?
Oh.
Yeah.
So, somebody asked me, what is the best technology? The answer is, what do you want to use it for, right? So you only want scaling when you want to make something digital, right? If you want to make analog, you may want some scaling. If you want to make power devices, you definitely want large areas, large dimensions. If you want to make optics, photonics, you are limited by wavelength of light. So why do I want 3 nanometers? It's not going to, it's no use. Yeah. So the thing that I like is innovations like this neural probe, right? They are new things. On top of that, you will probably not need some digital. You will probably need some analog. And if you look at chiplets, nobody wants to build everything on the same chip anyway. So as long as we do excellent things, the rest of it is not going to be a problem. So I think the question for us is that what is the exciting innovation at 180 that we can build? I think that's for all of us to answer, and I think each one of us have some ideas. I'll pause.
Great. Over to you, Reddy.
Hi. So the things which I personally see with 180, I'll talk about the negative first. What we don't have is speed. Though in the morning people were talking about speeds until 2 Gbps, the world is at 64 Gbps and 256 Gbps. So we don't have speed. But like Ganguly professor has told us, we don't have applications where you need speed. For example, a video which is running at 30 frames per second and a VGA, you don't need 10 Gbps of speed. Probably 1 to 2 Gbps is sufficient. So that's where we were proposing the IPs to the SCL. Also, take the version 1 of PCA, version 1 of SATA, which are low bandwidth and which are supporting multiple range of applications. That's on the speed portion. Second, what we are missing completely is the OTPs, EPROMs, and the MTPs. More importantly, I've seen your research a couple of days back. I didn't know you before. So I've just seen your research back. So we are in desperate need of OTPs because if you want to make a full product, you obviously will be in need of trimming. And one of the ways to do trimming is through the OTP or the MTP, preferably the EPROM later. So these two things are most critical. And the third one, which is sort of already addressed by the SCL team, we don't need speed, but you should be able to, the capacitance of is non-concern if you are handling high voltages. There's no need of speed. So if you have the devices to handle high voltages, like the 40 volt LDMOS which is coming up, or even higher versions of it, So that will be very beneficial in for example, in the chiplet for the power management unit. We can build all of that in 180 nanometer and minimize the cost significantly. So that's where I see the power of 180.
Yeah, thank you. Over to you, ma'am.
Thank you, sir. Basically, we work in a very niche area, I should say, the area of space. And as we know, space is a very harsh environment when compared to the ground applications of semiconductor devices. So, lower technology nodes, many of the cases, it doesn't suit our application because they are more prone to single event upsets, single event transients, which hamper the operation of the spacecraft. And as you know, once we launch a spacecraft into orbit, there is no way that we can go and repair it. It has to reliably work in the entire duration for which it is designed and launched. So 180 nanometer technology for us is definitely a great boon, I should say, especially having it in our SCL, a domestic foundry. We don't have any difficulty in realizing our designs. And SCL has geared up to meet our radiation requirements as well as additional requirements of shock, vibration, all those setups they are meeting for us. So 180 nanometer technology is a very promising technology for us for many of our devices, and the complexity what a 180 nanometer technology can handle can still be enhanced if we go ahead and make the devices same 180 nanometer technology on an SOI wafer. Thank you.
Yeah, thank you very much, madam, for sharing us insights. And we move to Dr. Sharma ji for sir taking up this same point.
Thank you, Deep. So my take is from a different perspective, probably because of my training. So if you look at the way things are moving, right, I just cite a recent report by McKinsey, which said that it took 55 years for the semiconductor industry to go up to $500 billion. But it would only take 10 more years to double it. So what happened in 55 years would happen in 5 years. And one of the reasons for that to happen is that the drivers now are aggregated over a very widespread space. You have advanced computing and communication. Udayan mentioned about it, digital applications and stuff like those. But you also have applications like, wireless. You have applications like automotive. Now, when I talk about automotive as an application, and this is just one of the applications, right? So when you talk about automotive and application, you probably never require such advanced technology nodes. One of the reasons for that is that with every advancement or scaling of technology node from a device perspective, you have a cost versus complexity trade-off. Now, we all know how that happens. So the question to ask is that, is it worth the effort given the application? Now, for all the startups that we have here, I think cost, complexity, and the third dimension is time is very important, right? All these things can be positively catered through the 180 nanometer legacy node, as we call it, from SCL, because it's in-house, it's mastered by them, they will deliver on time, and therefore you don't need to really, put all your eggs in one basket, so to say. That's one thing. And the last thing that sort of in the interest of time is that, today if you look at the overall system design, it's never a single standalone device, a single, digital IP or an analog IP. We're looking at a heterogeneously integrated system. And from an HI perspective, you would have the advanced technology nodes sitting to the legacy nodes, sitting to different processes, a GaN versus a, indium phosphide, et cetera, And therefore, while some of these advanced technology nodes could be borrowed and imported from companies in Far East, I think in-house capabilities that we have here at SCL could be exploited to the fullest to have a true HI sort of integration, for all the systems that you are interested in.
Thank you, Dr. Rohit. We move to Sagarji for your perspective sharing with the audience.
Thank you. I think most of the points are already covered since I'm the last speaker on this topic. But I'll just add some, perspective with respect to the national priority and the geopolitics of it. So,
Yes.
so if you see, the focus of most of the programs across the globe, be it the US CHIPS Act or the EU Act or a policy from Taiwan or Korea, they're more focused on the advanced nodes, for the obvious reasons. But for us who are entering into the volume business for the first time in semiconductors, I think the legacy nodes are a very good spot, because we are just going into the volume games. Now, if you see, we modified our program in 2022, to include the entire gamut of nodes. Initially, our program was supporting till around 65 nanometers, but then we opened it up based on multiple discussions and iterations with our advisory committee, with the industry experts. Now our program is node agnostic, like many other programs where the focus is more on the advanced nodes. So the geopolitics wise also for India, I think all legacy nodes, and specifically because 180 nanometer is a sweet spot for us, I completely agree. And because since already we have had some experience, so this is a comparatively much better, position with respect to the any other legacy nodes. And the other important thing is if you see the product culture, so even an iPhone has a 180 nanometer product, so it's not that, because the electronic device has product from all, like from micron level to maybe a 3 nanometer processor or a GPU. So and the different electronic product had different, technology node products. We all know that. So basically, there are applications which are in volume in this country, for example, railways, the passport chips, smart meters. So in next 3 to 4 years, there will be the requirement of 25 crore smart meters. But a chip, typical TI chip, which goes inside the smart meters costs around $840 today. So the market only through the smart meters is around $3 billion. So if we can master that particular one single chip for the smart meters, we will have a $3 billion market ready for us. Similarly, the market from the power transistor, and completely agree, with the earlier speakers on that. The passport chips, the chips for the Wi-Fi routers, chips for the CCTV cameras, So these are the products which are in abundance for the public procurement as well. So there is, I think, market-wise, I don't see any challenge, and there's comfortably around $6-7 billion market based on our calculation at the India Semiconductor Mission for 180 nanometer. So market-wise, we are very well placed. And now coming particularly to the SCL, so I completely agree with what Dr. Singh said, that the experience of volume manufacturing is something which we lack, and it can really help us, because getting into a volume-based model, and that too, if we can also explore the foundry model. Of course, we know that the SCL is an IDM, but the foundry model is a very different ballgame vis-a-vis an IDM. So that is one important aspect, and if we can sort of sharpen our skills there. Apart from that, there was one more point which the support for the startups, which we are already doing, but if we can make it even more formalized and do some more sort of kind of tweaking there in order to support the academia and the startups with a faster turnaround time. I think I think these are some things which are particularly to SCL. I think these are my observations.
Thank you very much, Sagar ji, for sharing your thoughts, your insights on this. Over to you, Rahul.
Yeah. Professor Rohit, you being an expert from packaging area, if I extend the discussion a little towards packaging, as we all discussed about the possible applications and possible uses of 180 nanometer node. Now, if we talk about the scenario of packaging, we hear a lot of things about packaging 2.5D, 3D, chip on chip. Many flavors are there in market. Now, if we redirect it to our 180 nanometer applications, how do you see the packaging should be explored to meet these kind of applications? And any comments regarding possible directions for packaging to meet the demands which we are discussing right now?
Okay, so the second question first, what corrections or what sort of improvements we can do is, I think one of the things that is very important is that, agnostic to the applications, from a package perspective, we cannot have electrical design alone as a sort of holy grail. We have to look at other aspects, and more importantly, thermal and mechanical reliability aspects. And therefore, today from a package design perspective, it is a co-design and a co-analysis sort of approach that we have to take, where electrical models, mechanical models, and thermal models sort of go hand in hand. So this is a very important sort of course correction that we are trying to do from the broader packaging community worldwide. That's the first part of it. The second part, in terms of the, for a specific 180 nanometer technology node, again, see, when we talk about packaging today, it's essentially advanced packaging and heterogeneous integration. So it's not dedicated to just one technology node. We have to look at some legacy nodes sitting with advanced nodes, 2 or 3 or more different processes sitting next to each other. So the whole package has to be designed, taken into consideration these different IPs. These could be chiplets, these could be separate standalone ICs, these could be SOCs. Now, and the last thing is also in terms of the process of interconnecting that plays a role here. You could have silicon bridges, which is for digital applications. You could have embedded bridges, which is an Intel sort of proprietary, so to say, right? So these are for advanced technology nodes, digital applications. But where you're talking about optics, silicon photonics, or analog blocks, what you require probably would be wire bonding, right? Which is very reliable, and I'm a strong advocate of wire bonding also, or flip chip, or BGA. So depending upon the kind of system that some of these startups are looking at, we may have to employ one or all of these into your entire HI package that you would see. I hope I answered your question.
Thank you.
Yeah, thank you, Rohit ji. Basically, you are saying that world started and world was looking into integration, and then they are looking into disintegration of heterogeneous packaging, bringing so many advantages. But one more question remains to particularly to Sagar ji, that we are talking of India Semiconductor mission, which is a driving force catalyzing the India's semiconductor ecosystem, basically. And recently we are witnessing, a great onshore manufacturing. After post-pandemic era, this has taught us that onshore manufacturing is extremely important, coming up of ATMP plants and manufacturing plants, fabrication. But as a policy, being inside the framework of policy making, or how do you see the international collaboration efforts in bringing up the resilient global, I'm not talking local, global supply chain which we can have? Can you share some of your thoughts in this vital area?
Thanks. Yeah. So I think my experience involving the policy for the India Semiconductor Mission for last 4.5 years. So we very well understand that semiconductor is a global industry. It's a typical semiconductor chip crosses international borders 70 times before being placed to the final consumer. So the supply chains are very diverse, and and of course they are precarious also. There are some vulnerabilities also in the supply chain. So for example, today 92% of the most advanced chips are coming from one small island. If there is something bad there, we are all are like in a very difficult situation. And COVID made us realize that in 2019-20 time framework, when the automobile industry faced a loss of around $110 billion in the year 2021 because of a 12-cent chip. So we all have to collaborate to make this supply chain more resilient, more diversified, more trusted, and more sustainable. And I think that was the message which really echoed well with the Honorable Prime Minister when we were sort of thinking about this entire policy and $10 billion support. That how we can, there is a philosophy of Vasudhaiva Kutumbakam in India, which says that the entire world is one family. And considering that the semiconductors are so integral to the modern human civilization, if there is, some issue with the supply of semiconductors, the human civilization is at stake today. So it's now an existential issue that we should enable, or we should do our part to make the supply chain more resilient, diversified, trusted, and sustainable. And that's how we started. That is the fundamental philosophy of our entire Semicon India program. And that's how we are collaborating. If you must have read in the news that we are collaborating with the like-minded countries across the world. So we have signed the memorandum of understanding with the government of the United States. We have a memorandum of cooperation with government of Japan. We have a memorandum of understanding with the European Union. We were there last 2 weeks back in the European Union to discuss that how we can collaborate with each other to make the semiconductor supply chain more resilient. And similarly, recently when the Honorable Prime Minister went to the Singapore, we signed a memorandum of understanding with the government of Singapore also. And we are working one with the government of ROK as well, Republic of Korea as well. So basically, all the like-minded countries where the semiconductor supply chain is there, we are working with them to make it more resilient. And we know that there are some things which we offer, like for example, talent. We are one of the youngest country on the planet today. Our median age is 28 years. And all the competing geographies in semiconductors, be it Taiwan, Japan, they're all aging economies. So we are correctly placed to support the semi-supply chain when it comes to the talent, because talent is one of the key pillars, which is the driver of the semi ecosystem. But then, we lack in certain areas, like for example, technology, and we are working with the different, for example, the example of Tata and PSMC is one example of cooperation where one Taiwanese company and an Indian companies are collaborating for establishing semiconductor foundry in India. So I think there is very clear understanding and appreciation of the fact within our framework that the global cooperation for the different facets of semiconductor supply chain is very, very important. And we are sort of doing every bit possible in order to further strengthen our efforts and those partnerships and collaboration to do our best to make the supply chain more resilient, diversified, trusted, and sustainable.
Thank you very much for enlightening us on this particular point. Over to you, Rahul. Yes.
It's a question to you. Regarding the space applications, would you like to enlighten and give us some highlights to startups? What kind of products or SOCs you anticipate or look for the requirements for the space application? Any ideas to startups?
For space applications, we look for different range of devices. Mainly, it can be purely a digital ASICs which cater to the various applications of the onboard computer, or it can be a pure analog device which we may use in the power systems, or it can be even mixed signal devices like the data converters, signal processing circuits. That is one portion. And another, coming to the technology wise, we look for memory devices where it can be an SRAM of higher densities. We also look forward to flash memories. Of course, OTP memory is what already Professor Ganguly is working on. And for an SOC which can operate at higher rates, especially when we have autonomous mission planning operations, where the control dynamics algorithm has to work at a very faster rate. That is one of the things that we are looking for. And AI-based applications which will be useful for us for trajectory planning, rovers, landers, etc. So, but above all, I should say, whatever we design, it has to withstand the environment of space, and it has to perform without any flaws, because any small failure, it can lead to a mission loss. So that is of utmost importance for our applications.
Thank you. Thank you very much, madam, for giving us the product list and the sort of things which we can develop. But also, very importantly, she in last touched that reliability is paramount. And Dr. Ganguly, you have been long associated with us, particularly on SCL 180 nanometer technology platform. So, you know that the OTP developments were taken up. But what I want to ask from you in particular for the audience is that please tell us, bringing the things from concept to qualified technology, how do you see the challenges and how long do you see this cycle is?
Thank you, Deep. So I think there are a lot of people here, Umapati ji, Avinash,
yes.
So we've been working for the last maybe 8 years, trying to take a technology and qualifying it. So we qualified it in 2020 as a for manufacturing, and now the chips are out. So 2024, we hopefully have enough users to fast track it. So there are some learnings.
Okay.
And the learnings are that you have to, not everything is theoretically known. One has to move quickly, accept that there is a cost of making mistakes. Realizing that, you know, that risk has to be mitigated in some way. For example, you know, there were times when runs were done before maintenance, right? So that the next lot would not be affected. So SCL has a unique challenge of running manufacturing and some R&D. How do you balance it is actually the piece of innovation, right? I think we need such champions who will enable those things. And I think then we can do flash, we can do other things.
But as a addition to this, when we take the approach of development of a technology flavors on the baseline technology, what approach? Is it a mix of in-house development plus technology transfers, or for the interest of, I'm talking all because it's a dynamic and fast field. So how do you?
Meaning you have a customer, you get the best possible that you have budget for, right? If you can get it from somewhere, get it. The discussion we've had, Deep, is that even when you get technology from somewhere else, it's like, you know, you get somebody's microprocessor. Today there was discussion of ST microelectronic 32. Suppose somebody gives you the design, you still don't know why it works.
Yeah, so you have to decode it.
So I think it's a mix of both. And if you don't yourself know what's going on, then the first time something goes wrong, you're in deep trouble. So I think it's both, and it's probably both in parallel, and now which one you prioritize first is up to you. But
Gulati sir, would you like to add this perspective particularly? Anything on this?
What he's saying is very right.
Okay.
Technology is important. But at the same time, when you're taking in a technology, you have to absorb it. You just can't take in a technology and just make it, and without understanding what's going behind it. So in CDL, what we've done is every time we've developed a technology in the last 2.5 years, 2 years, we've developed the silicon carbide technology of OSAT. I'm not saying the fab side. So it took us, we developed it, we went back, kept going back and forth. So technology is something that we need to really understand. And now today I can say very proudly that our silicon carbide technology has attracted so much of international attention that we're getting customers coming in from Korea, US, Japan, and wanting to see with their eyes that, oh my God, you're doing it. How are you doing this? How are you able to manage this? So it's important. Now coming back to SCL, we've worked with you for quite some time. You developed the wafer for us, one of the product families. And I said, as I said in the morning, we have about 8 or 9 product families. Now we are into the discrete segment again. I'm touching. SCL has a very good fab processing, technology, facilities, but there are certain segments that SCL needs to augment now, add to complete this discrete. And those segments that I find probably it's because of cross-contamination or whatever reasons. In any discrete, the last process is a grinding. And I do not think SCL has a grinding equipment as of now. Then after that, there is a back metallization, like I think Professor Sharma was saying, the different type of metallizations. We are today doing aluminum wire bonding. We're doing clip bonding. I'm going to do ribbon aluminum bonding. So there are 3 or 4 wire bonding technologies that we have developed in-house, and we have tried them out. To use those technologies, we need the fab to support us. Today, I'm working with the foundry outside, and they're able to give it to us. But all this that I'm telling you is this limited resources have to be filled in. And my estimate, if you really want to go into, I'm just touching the discrete area, MOSFETs, IGBTs, power transistors can never be integrated. I mean, they need high power, everything. Silicon carbide, I believe, will not be integrated for a long time. So if you want to get into this, there are certain 5, 6 areas that SCL needs to augment, add, grinding, back metallization, which means gold, phosphorus gold, tri-metal, sintering. They're just that segment of the back end, which probably my estimate will not cost more than $1 million.
Sure, sure, sir.
So if you do that, you'll be a fully integrated foundry for us at least, and we can load you with quite a bit of number of 8-inch wafers.
Thank you. Thank you very much. Over to you, Rahul.
Yeah, just to add on, we are in the process of adding this grinding process, and as you suggested, the remaining process also we can discuss and explore further. Yeah. Yeah. Coming to next question, Mr. Rohit. Yeah. Actually, you are coming from the design background.
Yeah.
So I would like to have your thoughts on. As we all are aware, India is having a big design team.
Yes.
But not much doing for India. We don't have much IPs in India.
Yeah.
So how do you see when the all momentum is gearing up? What are the challenges you see for the Indian community to take up this design challenge and build up more and more IPs in India?
Yeah, like I talked about, the speed issue is one of the things. But having said that, there are many applications where we can use the speed. The other question is, who is buying it? So even if you develop it, for example, now that SCL is looking for multiple IPs published in the list today, we have some sort of a customer, but otherwise who is buying it? Basically, finding the customer is a big challenge because the cost to get it done with the tools and stuff is quite high. And now if you don't have a customer, it's even more difficult to survive. So that's one of the major challenges. In terms of design skill to do work, I mean, in terms of thinking about design, there's plenty of talent. It is just about getting the tool access, like already it's been addressed, and getting the customers, which are the challenges.
Would you like to touch upon the IndySemic question which was raised in the morning related to the RTL to FPGA?
Yes.
Just quick and brief view. Yeah.
Yeah, so what I understood, correct me if I'm wrong, is you have something proven on the FPGA, and then you want to convert it into silicon, basically to mass production. Right. Yes. We are fully capable of supporting that kind of a work, and a lot of companies are also there who do similar thing. On top of it, along with the RTL to GDS, usually have a physical layer PHY, which is the connecting segment between two things which are a little bit far apart. So we also do that as well. Yeah. Thank you.
Thank you. This is an announcement for the audience that very soon we will be taking the questions from the audience. Please prepare up your questions. We are moving to the last round of discussion. Now this question again goes, sir, you want to add? Please. Yeah.
One thing, presentations this morning and initially also when we started SCL, I see a lot of things happening, variety of things, IPs and products and sensors, MEMS, everything, and now discrete devices also. Pankaj, my friend, he has brought to you. So that is fine, but I think to focus on one or two things is also very important to my mind. And the kind of, I know the boys here, Homopathy and others, and the technological strength of SCL, the high voltage devices and power management devices, RAID hard devices. This could be the focus, perhaps, from my point of view. So we have to succeed at least one of these things or two of these things. Successful from the point of view of the market. Somebody scales up, takes to the market, and then that device starts earning that. And one thing I see Subhajit sitting in the audience, and he has one of the oldest fellow from SCL. I would like invite him to say something on this.
Okay, so we will take it during the audience in particular, yes, with the sir, and yeah, surely. Thank you very much, sir. And I think it's a last round, which is basically what there is a lot of startups who are joining this event. Now, I would like to ask our esteemed panelists, in just one line or two line, a practical piece of advice which we would like to pass on to these young entrepreneurs to get success in their journey ahead, starting from the Sagarji.
I think we should give the experience to the whole.
Okay. So, sir, just one or two lines, practical piece of advice.
Dare it. Go ahead and dare it. You will succeed. I mean, of course, there are going to be failures, but that should not take us back. personally, I've had many failures. Believe me, in these 40 years of semiconductor, I've had many failures. I'm not an entrepreneur or started any startup, but every one of us, we have to dare it. Take a decision, do not delay, and go ahead with it.
Very
That's all
good,
I'll
sir.
say.
Thank you very much. Dr. Dean Singh.
I will say that when you were in a startup and then you are building a product to be successful, market is very important. Like Ansman Tripathi was saying, then you see that what kind of devices are there equivalent to that in the market, and which you are going to replace and are going to take a similar device, and how do you do it? So go to the board level, how this will work on the board level, and how the market will react to that, whether the market will accept it or not. So since very beginning, the market has to be in focus for which you are building that device.
Dr. Ganguly.
Yeah, so three things: customer,
things.
customer,
Okay.
customer.
Okay, thank you. Over to you, Rohit.
Yeah, I think what Professor Ganguly has said, along with the customer, what he has said previously is to have some sort of strategic scheme where you allow yourself multiple times to fail, because there's no secret to success. You just fail more number of times faster than others. So that's the key.
Madam.
In my view, it's just persistence, patience, and every problem always has a solution. No problem appears without a solution. So stay calm with perseverance and patience. That's all.
Good, thank you. Dr. Rohit.
So, apart from what has been said, a couple of points. One is, take risk, but don't be reckless. That's very important. And the second is what, the traditional Indian industry has not been able to do it. You probably could do it, is please collaborate with academia. Across the globe, you talk about Far East, you talk about Europe, and you talk about North America. The semiconductor growth has happened because of very close collaboration with industry. These silos have to be broken. Our large cap, mid caps, this cap, that cap hasn't done so far. But you can be a trailblazer and you can do this. Thank you.
Yeah, I think all the points have already been covered, but I just want to tell you that the India Semiconductor Mission is with you, and you can always reach out to us with any request and how we can better support you.
So dear startups, in the last round you heard, you dare it, know your market, know your customers, be persistent and be patient, have an academic collaborations, and in the last, don't forget there is an ISM body sitting behind you. So with this, I am opening the complete session for the audience. Yeah, maybe we can take 1 or 2 questions fast. Please, sir, carry on. Yeah.
I have heard the mention of industry and industries collaborating with academia.
Sorry, sir. Because of the paucity of time, Dr. Ganguly has to leave to airport. So we will just facilitate him and felicitate him, and then we will move on. Sorry. Yeah.
We request Director General SCL to come to the stage and felicitate Dr. Ganguly.
Sorry, gentlemen. Yeah, please, can you repeat your question? Yeah. And your question is targeted to some panelists. If you can please speak.
No,
Yeah.
it's about actually the academicians leaving.
Okay, no, he's with us. With us, Dr. Rohit is also there. Yeah, from IT.
I've heard a lot of mentions about industries collaborating with academia, but in my past experience, I've often found that academia cannot keep up with the pace of the industry. How do you think we as industries and academia can get down to the same level and work together?
Yes and no. I mean, yeah, it has been in the past seen that industry has a different quarter to quarter, sort of timelines. Academicians have no timelines, all right? So that is a fact. Having said that, there have been several examples, where academicians have delivered and have delivered on time. It's about finding the right pieces, right persons. Chemistry here is more important in semiconductors per se. I'll give you an example. I'll give you my example with SCL. Today in one of the videos, the Vikram processor was shown. It's a very proud moment for us personally because the package design was done with our group and SCL. I think Krishan is, he's not here right now. So Gurvinderji is there. So we all sat multiple times, and I shameless marketing, but I never gave an excuse, oh, I'm busy or I won't be coming. Similarly with Udyan as an example, or there's so many. So you have to do searching around here, just like you hire manpower and some of them do excellent, some of them don't. The same applies here. One last thing, we also have added pressure now. So those days are gone when it was like, we were living in our silos and we'll do academic paper-based research. Those times are gone. We have pressure to work with industry, and it's our passion also to deliver with industry, right? If we miss the bus this time, probably we'll miss it forever. So please have faith in us.
Thank you, Dr. Rohit. You have given the answer very passionately. Yeah, this is the scenario emerging. Please carry on. Yeah.
Yeah, hi. The question is from the facilities background, meaning the clean room, utilities, etc. So if we have any product and if we want to work with academia or any government agency, the only way to work is via tenders. And that becomes a roadblock if you have a promising product and if you have some concept and if you want to collaborate, there is only one channel available. And as we would like to take it on fast track, this option would not work. So what is an alternative? One. Second question, what are the thoughts on the refurbishment equipments? Because we are very much silent on that. The semiconductor ecosystem is developing. So is there any policy on the refurbishment equipments and allied domains? Thank you.
Maybe if somebody can, yeah.
Yeah, so I think for the refurbished equipment, we consider that as a part of the eligible capex, provided that there should be a particular amount of residual life. Yeah, it's 5 years. 5 years. So 5 years residual life should be there with the equipment, then we can consider. So because we understand that the refurbished equipment, and particularly for the classical nodes, the new equipments are not there in the market itself. So there is a consideration for an understanding about the refurbished equipments in the system. Yeah.
And he's right. We are doing it. We are importing because a lot of fab equipment and a lot of assembly equipment, we are importing refurbished equipment. I was under the impression 10, but it's 5. So and it works perfectly well because before you bring it in, you get it refurbished from outside. You bring it in, and that's allowed within the policy framework.
Thank you, sir. Yeah, please.
Hi, my name is Vaibhav Srivastav, and I'm the founder of WatchMe. We are a wearable product solutions startup. We can say in a nutshell that we have made a de facto operating system which is built over raw Android. Now, wearable hardware is an input for us, and we currently source it from China. In the market, currently we are selling for children smartwatches, children safety smartwatches. Okay, so that's where in the B2C sector we have started. We were just last week we were at the India Mobile Congress, and we can customize our solution for military, for corporate, for a range of sectors. And going forward, a very key component which is required is indigenous hardware. And we tried a lot to get the hardware done in India in the past few years, but it was quite difficult. We tried to contact MediaTek. They asked for $1 million upfront license fees. We contacted them 2 years back, then their rate had gone down to $400,000. We can't afford that. Then Uni SOC is a Chinese player. They have an office in Sector 62 Noida. We talked to them. They will work with quantities about 1 million pieces a month. We can't do that. So then I came across the Shakti processors. So my curiosity is that we have a operating system we can customize for different, but I need the raw platform. So I need to collaborate with somebody. Maybe the academy can connect me. We have talked to some people here. So I'm looking to collaborate with somebody on that. And what is the best way and the fastest way to get an indigenous hardware? Because once we can do that, we can really export the product a lot, and we can work in a lot of industries. I'm getting queries from Army for our solution. It is a very versatile solution, but hardware is something I would want to collaborate.
Yes, yes. So you have a promising market in front of you, but you want to get the indigenous piece of hardware as fast as possible.
Yes. For example, even now I'm trying to sell. I get queries from Dubai. I can't support the frequencies there. I'm talking about the 4G frequency. Very promising market in Europe, and we can really give a China for this money, because China has Chinese companies have about more than 90%, and they probably supply 100% of the components.
So, I think maybe Sagarji or maybe somebody can or Vivek Kaneja ji is in midst of us. Yes, he can.
You can probably go and tap into. One of them is Mindgrove. Madhu was there in the morning, so you can probably talk to them. The other one is Encore. You can talk to Dr. Neil Gala. Madhu was there. So Mindgrove, Shashwat, you can talk. I'll give you the numbers. So Mindgrove is mainly on the SoCs, whereas Encore is mainly on the SOC, is on the core. There are people who are doing in-house 4G and 5G modems, including the startups which are incubated at IIT Hyderabad, Professor Kiran Kuchi's team. You can try and discuss with them. Yeah, so I'll give you the contacts. Please talk to them, because you will have to specify what hardware you need, because it will have to be customized. I mean, you will have a core, you will have a 5G modem, and there will be some other peripherals, including maybe a touchscreen interface.
Yes, if my product is in the market, I have absolutely no.
Yes, so I can give you those contacts. Please talk to them and see if these guys are interested in the kind of volumes that you have, and what is the kind of development cost that they have.
So these contact points you can later on take up for. You have something.
Just one 15-second thing. For the design and prototyping, if you are interested, please get back to us. We'll be very happy to help you out here.
Okay, you can note it down for the design and packaging side, right?
I'll just also add. You please. You also please write to me. I'll send you I'll share my card with you, and I'll also connect you with couple of.
Oh, thank you. And with this, you have very quick. We have a last question with you, and very quick. Yeah, please carry on.
So one very generic question. I want to hear from SCL as well. Like, what is SCL's vision?
Vision, like okay.
Vision meaning we are talking of ये equipment है, ये बन सकता है वगैरह वगैरह. But करना क्या है? वो जानना चाहता हूँ. I mean, I am very happy with whatever SCL is doing for me, so no questions there. But generically, I want to understand where are we headed.
Sir is with us. Yeah.
I have shown you one slide that we can be a catalyst for a very strong ecosystem in this country. And that is why we are supporting in lot of domains. You can see we are not only working in sensor domain, we are working in 8-inch, we are working in CMOS detectors also in our domain. Even you can say we are IDM, but we are also doing board designing also. We are also repairing some boards also for strategic customers. So we are a very unique things which we are doing it. So whatever your applications are, you don't come to us for a small things itself. Wherever the specific needs are there, wherever your specific boards or niche products are there, we are very happy to work with you to bring out the solutions for you, because we are a one-stop solution for you. So our vision is to take the country forward in the Atmanirbharta type of things, where we can do the products where country needs it, where strategic sector needs it, where the import can be stopped for the strategic sectors, as well as in the commercial domain also, where the bulk market is there. We are very happy to do. And I think the worst, is there itself. You can see the CDIL process which comes to us. We are not only do the STCAD simulations, we have done the fab also. Within 4 weeks, the first run was out. We have characterized it also within 5 weeks. We have given the inputs within 5 weeks. Next lot also we run within 5 weeks. We have characterized it, and within 5 weeks the second lot also they got the feedback. So that type of capability which is existing. So you can take from us that type of capabilities. But if you see you make millions or some things, we have a pilot line. We can't do that.
Yeah, thank you very much, sir. And with this, we come to the close of this session. We are very thankful to all our dear panelists, distinguished speakers who have very candidly, they have opened up their hearts and they have given you the practical advice, their insights, their viewpoints. And we are very thankful to all. Let us give a very big round of applause for their appreciation. Thank you very much. Thank you, Rahul. Yeah.
So please stage on the stage. We request DGSCL and EDCDAC to kindly come to the stage and present token of gratitude to all our panelists here.
सबसे पहले मैं महानिदेशक SCL से अनुरोध करता हूं कि वे DN सिंह सर को सम्मानित करें। DN सिंह सर को बोलते जाओ।
Now I would request DGSCL.
डॉक्टर पंकज गुलाटी,
Thank you, sir. I request EDCDAC to present token of gratitude to Professor Rohit Sharma. So please. Thank you.
महानिदेशक से अनुरोध है कि वे मिस्टर सागर शर्मा को सम्मानित करें।
And I would request EDCDAC to present a token of gratitude to Madam Padma Priya.
डायरेक्टर जनरल SCL से अनुरोध है कि वो मिस्टर रोहित रेड्डी को सम्मानित करें।
Please give a big round of applause. Thank you, everyone. Thank you very much. Okay, so we request all the panelists to have a group photographs with DGSCL and EDCDAC.
Deep sir. Moderators also.
Sir,
Rahul.
नहीं start करते रहते।
सर आ गया बोर्ड से आ गया बहुत पीछे है बहुत हां सर और बना दो चल पीछे चल सर पीछे करो आप लोग आ जाओ बस आई सर आ गया
Ladies and gentlemen, as we come to the conclusion of today's event, I want to take a moment to express our deepest gratitude for your participation. Your presence and engagement have truly made this event a successful. Indeed, it was an uplifting and a productive day.
A heartfelt thank you goes to our esteemed speakers who shared their invaluable insights, and to all the participants for their thoughtful contributions. A big round of applause to our organizing team, on stage, backstage, volunteers. Thank you all for your tirelessly effort in ensuring that event ran smoothly.
Let's also extend our appreciation to our sponsor, CDAC, ED CDAC from Noida, our DG SCL, our controller SCL, our SCL colleagues who have made this event possible. As we close, we hope that the ideas and connection made here today would inspire everyone and motivate you as you move forward.
और अंत में इन 4 लाइनों के साथ हम इस एक दिन की मीट का सुखद समापन करते हैं। मंजिलों का सफ़र अब ख़त्म हुआ, हर एक कदम नए सपनों से जुड़ा। मंजिलों का सफ़र अब ख़त्म हुआ, हर एक कदम नए सपनों से जुड़ा। टेक के इस जहां में हमने कई राहें पाई। आज के सफ़र में हर दिल में एक चाहत जगाई। नई सोच, नए इरादे लेकर जा रहे हैं सब। ये रहे याद हमेशा कि दिल के रहेंगे करीब तब। तकनीक के इस सफ़र को हमने रंगों से सजाया। अब अलविदा का वक्त है, पर ख्वाब में नया रास्ता दिखाया है। जय हिंद, जय भारत, धन्यवाद।
Thank you. Yes, so before you leave, we have a tea for you. So have a safe journey. Goodbye. Thank you.
Thank you, sir.